Okay. Yeah, I should have gone to bed earlier, but I was like, I have to ride to talk. No, I just figured I could. So many of the slides originally I assumed were the same that I figured it would be mostly the same, and then I started thinking, oh no, this should be different on the second day, and this should be different on the second day. So, and there were so many other things that needed like management. I'm like, oh, this can be done, right beforehand. I'm not the right one to ask right now. Yeah. I mean, I want to start on time, but wait a couple minutes. Hello, and welcome back for day 2 of Pi Cascades. I'm Esty Shea. I am the other co-chair, and we're going to do some quick announcements and then get the talk started. We're going to start out with the land acknowledgement. We acknowledge that this land rests on the traditional village sites of Multnomah, Wasco, Cowlitz, Clackamas, Chinook, Tualatin, Molalla, and many other tribes who made their homes along the Columbia River. We take this opportunity to thank the original caretakers of the land. Review of some of the logistics. There's the Wi-Fi password. Restrooms are outside the main auditorium with the gender neutral bathrooms downstairs. Snacks are provided downstairs, and we have a new setup so you can go on both sides of the table. That should move a lot faster than yesterday. Apologies for the long line at the refreshments in the afternoon. The quiet room is outside the auditorium on the right in the sunset room. Sponsors are still outside in the hallway, so if you haven't chatted with them, please do. They do a lot to support us to make this event happen. And the mother's room, if you need it, is downstairs in the CloudBolt office. If you need it today and you didn't find it yesterday, please ask a volunteer for assistance. And if you didn't pick up your t-shirt yet, we have a ton of t-shirts at Reg, so please go grab one. Also, we are live streaming. If you didn't see the tweets yesterday, we actually have the captions going now too, so tell your friends. The current stream URL should be in those tweets. And yesterday's morning videos are up. More videos will be loaded. The Python community is a great community. When you're meeting people and working with your colleagues today, please remember to be welcoming, be supportive, be respectful, open, and positive, and make sure everybody has a great con experience. And we have such a great community that during our 2 grant programs this year, we were able to give over $15,000 to allow people to come who otherwise would not be able to join us this conference. So, yay, Python. Review of the Code of Conduct. It's on the website. It was part of the registration process. This applies to all the conference spaces. And remember, this is the Code of Conduct is a minimum, not the standard. We have a great community, so be supportive of the folks that you meet here. If you do want to report a concern, we've got the hotline. We've got the email contact@picascades.com. We do keep reporters' names confidential. And if you have an issue with a staff member, please email me or Eric directly. And along those lines, please respect people's choices of whether or not to be in photos. When you're taking photos, when you're posting photos, make sure they don't have people wearing blue lanyards in them. And thank you to everyone who opted in to participate in yesterday's photo at the end of the day. We really love having this visual reminder of how many awesome people were here with us. So make friends, learn something new, have fun, and please eat the food. We ordered way too much. And we have takeout containers at the end when we're packing up. When you're chatting, remember the Pac-Man rule, as Eric mentioned yesterday. When you're in a circle, leave a gap so new people to the community, new people that you haven't run into, feel welcome to approach you and participate in your conversation. Now, quick review of the format. It's going to be the same as yesterday, 25-minute talks, 10-minute breaks. No audience Q&A at Pi Cascades. That's why we leave this nice wide area. So after the talk, during the break, the speakers will be up front to chat and talk, answer questions. Lunch is not provided. We invite you to explore Portland's wonderful food scene. And we will, again, have lightning talks after lunch. So if you have a topic you want to talk about, go to registration and sign up. We're really excited that people are making use of our new open spaces across the hall. That was created in response to feedback we got from the conference last year. And here are some of the talks that we've got on the schedule already today, but there are plenty of spots still open. I think you should attend the talks here on the main stage because they're awesome too, but we do offer this opportunity to chat with your colleagues. And so we are having sprints here, same building tomorrow. So thank you to those of you who are sticking around. If you do have the flexibility to hang out, we have, I believe, 8 projects already signed up. So check them out on the website, and we will be feeding you lunch tomorrow. And stay in touch today and after the conference. The link to join our Slack is on the website. We're on Twitter. And if you need to talk to us about something not COC related, go ahead and email organizers at PyCascades. And once again, we want to thank our sponsors because they really help out making this event happen. Microsoft Azure, Nexmo, Twilio, Mozilla, Rover, CloudBolt, RealPython, and API Metrics. Thank you for your contributions to make this event happen. Yes. Thank you all for coming, and don't forget to be awesome. And now on to Nina and Thea. They have an announcement.
Hi, we wanted to quickly recognize the winner of the batch decorating contest. Drum roll, please. Ta-da! Yes, so Charmaine Worthy made this beautiful badge, this desert high mountain sunscape, and I absolutely adore it. So if Charmaine is here, or if anyone knows where she is, there's this awesome Circuit Playground Express waiting for her that she can code with CircuitPython. So if she can come and find me, I have her amazing prize. Take a look at this work of art. I hope this inspires you all to decorate your badges today. We still have lots of supplies and stickers available, so please have fun.
All right, and we're going to get set up for the next talk. I got to it.
tried to lost my heartbreak on the ground. Lost you decide if I just hit me.
morning. Welcome to Sunday. For our first talk, we have Terry Oda, who's going to give us a talk about MicroPython. Take it away.
Hello, Portland. So, your first question when you look at this talk may be, why would I want to build a decimal meter? I already have one. It's in my pocket. I could just download an app anytime, even in the middle of the night, and find out exactly how loudly my spouse is snoring. Not that I know this from personal experience. So, for the answer to that, for the answer to why I'm building a decimal meter, we need to go down to beautiful, sunny Albuquerque, New Mexico. So I lived in New Mexico for 2 years while I was doing my postdoc at the University of New Mexico, and I was heavily involved with the maker community there. And they do all kinds of cool things, but one of the cool things that's relevant today is the Albuquerque Mini Maker Fair, which is kind of a show and tell, a showcase of local things that people have built. And they do these all over the world, and Albuquerque's is my favorite, not only because I was there when it started, but also because not only do they have you go and look and see things that other people have built, or go and buy things from local makers, but they also have a huge component where you show up at the Maker Fair and you actually build something yourself. And so one of the things that they do, that you build yourselves, there's a whole bunch of things. You can do silk screening and t-shirt surgery and build robots and whatever. But one of the things they do is teach people to solder. And after the fair had been running for a couple of years, they had a problem. There's only so many really tiny, cute soldering kits available and easy to get for them, and people had done them all. So there's a lot of kids at the fair. They show up, and the saddest thing ever is when you watch an 8-year-old come up to the booth, and their mom says, "You did all those last year. I'm not buying you another soldering kit." So this was sad. And my husband said, "Well, we can fix that. I'll just build you a soldering kit." My husband had pretty much no experience doing hardware at this point. But, you know, we're makers. The team that actually runs the Maker Fair was like, okay, sure, whatever. Well, yeah, if you show up with hardware, we'll do it. And so he built this kit, you can see up here, with the balloons on it. And that was his first hardware kit. It's beautiful. It's not very complicated electrically, but it's lovely. And it's balloons because Albuquerque hosts the largest balloon festival in the world. And we used to run the Maker Fair out of the same space. So that was pretty cool. Everyone was really happy. And then the kids were like, so I've been doing this for a couple of years. I want to do surface mount, which is a little harder. What we learned from doing the surface mount kit is that if you are 8 years old, you are going to rock that thing. You are going to be able to surface mount solder, no problem. If you're an adult, sort of 50-50 is whether you're going to be successful at this one. So, okay, we wanted to step up our game some more. And by this point, I was like, hey, John, you have to learn MicroPython because I'm giving a tutorial at Open Source Bridge and I need you to TA for me. And thankfully, he was game. So the 2018 kit is based on the tutorial we did, which was build your own open source internet-connected barometer, because you know that's a thing you need. And in fact, it actually was a thing I needed when I lived in Albuquerque because my front sunroom got ridiculously hot and I wanted to know whether I needed to water my plants extra. And then we got to last year. And I was like, okay, this is fine, but my husband's been doing all the actual electrical routing, and he doesn't know anything. I can do this. So I have even less hardware experience than my husband at this point. My expertise is in computer security. So mostly I'm known for breaking things, not making things. But I put on my shield of arrogance and say, I'm going to do this, and I'm going to do this year. And it doesn't matter that I have a 1.5-year-old who is convinced that any screen mom touches is really just a vessel for showing dog videos. We're going to make it work. And I did. And so this is my kit. Like the first one, is very simple. My favorite part of this kit is that it has a switch so you can turn it on and off, because for those of you who have children, you may note that when you build these things, if you have to take the battery out to turn it off, you're never finding that battery again. So this one has a switch. So we went to the Maker Faire. I saw people building my kit. People actually bought my kit. Like, now I can say I'm a professional hardware designer. People paid for my stuff. I'm hooked. So that's why I build soldering kits, but why might you want to build a soldering kit? So number one, it's something simple. That little prickly pear with the lights is basically the hardware equivalent of a Hello World program. Printed circuit boards are cheap, so this is a hobby that you can get into with fairly minimal investment. The assembly is where it gets hard because you have to do bigger runs. So it's a great way to try it out, see if you like it before you get too committed. You get to learn new things. I love learning new things. And it's a great gateway to bigger projects. So if you've been looking at other conferences and their fancy electronic badges, yeah, this is where you start for that. So the first thing I do, well, okay, let's be honest. I do this constantly. I just scribble down terrible ideas for things I want to build all the time. But this is some of the brainstorming for soldering kits. You can see up in the top there's the red, green, and Christmas. That was the one that ended up being the surface mount board. There's a bunch that we've never used. You can see I've got a nice little Python one that I thought maybe I would do for some Python-related conference sometime. So we talked yesterday about constraints being really helpful for creativity. So here's the constraints that I operate when I'm building a soldering kit. Number one is cost. Albuquerque is not as rich as Portland. People do not want to spend a whole lot of money on these soldering kits. Number two is time to assemble. As I said, a lot of the people who are building these kits are kids. Some of them have siblings who do not want to sit there and watch them solder for half an hour. And then the last one is this thing going to be useful when you're done? I don't really want to make so much more e-waste in the world. So those kits that you saw, even the ones that just blinked a little light, have magnetic backs on them, so you can wear them at the Maker Faire, and then you can take it home and you can put it on your fridge or you can put it in your locker. So they're a nice souvenir then. And obviously the Internet Barometer we designed so that you could use it for other things. And if you're wondering what the picture is, that is my child discovering that my washing machine is not only good for washing clothes, but it's also baby TV if you put a flashlight and watch what's going on inside. He can sit there for hours. So, decibel meter. What does it look like? Rock on! So I did, before giving this talk and before designing the board, look up how offensive that is in various countries. It turns out that if you add some gestures, it can be pretty offensive in Europe, but it does seem like even Unicode knows it as the horns. So I had just been to a metal concert when I was designing these things. So the core components here are, I've got a microphone, I've got some sort of processor, I'm going to have some lights, I'm going to have a battery for some power. I could use it for a few other things. I could reprogram it to be a guitar tuner. There's someone on Hackaday just a couple of weeks ago made an internet-connected listening device with basically the same setup, only no bright lights to tell people that it was a listening device. You could have a sound-activated nightlight. Again, I have a 2-year-old. It's a great little MicroPython intro board. And if you're trying to design your own thing, you basically just sub in something differently for that first sensor. So if you don't like microphones, then you could get maybe an accelerometer, and then you've got an internet-connected level. I don't know what you do with that, but you might think of something. Or, again, a toddler entertainment device. So, yeah. Okay, so I know what I'm going to build. What am I going to build it with? So my first step is choosing some sort of building blocks for this. If you've never done this before, it's a little overwhelming. So you go to DigiKey, which is a big parts store, and I try to find some LEDs, and I get 13,000 results. And I don't know that much about hardware, and I have no idea how to narrow that down. But you sort of think about it, okay, I know it's going to be through-hole. I want them to be about this size. Do I just choose the cheapest and most available? Do I it's confusing. So after you've done it a couple of times, then you tend to just say, I'm going to use this bag of leftover parts for my last project, which is much easier. So here's the bag of leftover parts from my last project. This is the Node MCU board. If you buy them in bulk, you can get them for about $2. So meets my cost constraints. It's Wi-Fi enabled. It runs MicroPython, and we used it in the Cloud Sun kit, so I have some around. But I hadn't used a microphone before. So I could have, and probably should have, spent a lot of time figuring out which ones worked, but I did a couple of searches, and it didn't seem like there was a winner as far as microphones go. They're all electrically compatible. So what I did was I was heading up to Canada to visit my family, and I just bought everything that Adafruit had, because the fine folk at Adafruit have excellent hardware support and tutorials, and I was pretty convinced that one of these was going to work. And in fact, the first one that I plugged in worked. So I have a handful of microphones that I will use for future projects. So we got some hardware. Let's write some code. So if you're not familiar with MicroPython, it's Python for small things, so microcontrollers. It is a huge improvement over previous experiences you would have with actually wiring this up and programming it. It's much easier. In the case of MicroPython, you just plug in a USB, or you can actually do it over the Wi-Fi and talk directly to it. It gives you a nice little Python prompt, and you just type code right in there if you want, and then save it into a file to run. So it is a really great beginner experience if you want to try playing with hardware. Okay, so as I said, the hello world of hardware is make a light blink. So it's really tempting to just go and plug a light in and see how it works. But the pins on my board, which you can't really see there because they're super tiny, you can barely see them on there, are labeled with a bunch of letters and numbers that you may or may not know. Like, I recognize TX and RX, that's the transmit and receive, so I'm not going to use those lights because they're going to be the ones that are used for the Wi-Fi. So thankfully, you can look this up. And so I looked it up, and I figured out I could use the following pins. I could use D1, D2, D5, D6, D7, and D8. And you'll note that I have those in as comments. That's what's written on my board. But the pin numbers are completely different. You're never going to figure them out. Just look it up. The magic here for the hardware talking is importing that machine library, which says, this is how I talk to this hardware. So I'm super excited. I wire these things all up, and I run my code, and it goes blink, 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 blink. 2 of them don't work. Why? So I start playing with it. I'm like, okay, well, maybe I have too many plugged into one line. And sure enough, if I plug in enough lights, I can get one of them to turn off. But that's obviously not the problem with these two, with pin D7 and D6. So I try wiring them the other way. Finally, I try a new board, and it works just fine. There was something wrong with my original board. Thank goodness I have a box of them in the basement. Hardware is hard. Testing is really important. So next up, I plug in my mic. So now I've got the same machine library, and then I've got time and math as well, which I'll be using shortly. So the mic, I've done my reading now at this point. I'm no longer just buying random stuff on the internet. The mic can connect to one port. It's the ADC port, which is the audio, analog to digital converter. It's the only one that works, and I won't be able to use that for anything else. But it's okay. I'm building a soldering kit that only does one thing. That's fine. So I go in, and I want to get a little audio sample. So that's the code for that. It's just basically doing a read over and over again, as fast as the code and the board will do it. So when I do that, I get this. You can see that this is done when it's quiet. Shocking in my house, I know. I have a 2-year-old. It's quiet. All of my signals are about the same. So then I pick up the board and go, ha. And I get this one. And if you were thinking that what you would do would just be like, if it's bigger than this number, I would do something, then you realize that you have made a tactical error. So those numbers are all over the map. But I have learned that my mic is working because quiet looked different than loud. So for those of you who actually know something about audio and remember your high school physics class, you're probably knowing where this is going, but it's giving me a waveform. If I want the volume, I sort of want the height of that. And I could pull out my high school physics textbooks and do that, but actually somebody already did. So thank you, nice people at Adafruit. They wrote this for CircuitPython, which is their fork of MicroPython, which is totally awesome, but doesn't run on my cheap $2 board. So this does the calculation for me, and I can get, okay, now my quiet sample is quieter than my loud sample. Awesome. Let's make it work. So I could do something fancy, or I could do what we know in the science world as the empirical route, which if you see in a paper that something says, these values were empirically defined, that means we tried a bunch of things until we found something that worked. So that's what I did. So these are the numbers that worked. I could do some much fancier things. You can do proper log scaling, and again, the fine folk at Adafruit already have that code for you, so you can use it. But this is what I did. It turns on and off. Pretty good, well enough for what I need. And I could show that everything is working. So as a coder, it's tempting to now spend a whole bunch of time refining this and have it do pretty fall-offs. But no, I need to order my hardware. So I use KiCad, which is open source design software. It's pretty popular in the makerspace because the alternatives are very expensive. Okay, so I'm updating my design sketch, still got my hand sign. I have remembered that I do in fact need a battery and power is not magically appearing from the air. I have figured out that I can only have 6 LEDs because all the other ones don't work. And I've got sort of a layout of where things are going to go. So if I have done these things nice and linearly like I'm telling you, then I already have a nice setup with my breadboard, and I can translate it to a circuit diagram. Every time I go in here, I think, oh, I'm just going to put some parts on there. No, you have to have a circuit diagram first. And you can actually see that I'm cheating in this one because the mic doesn't have an actual symbol. It's just 3 random connectors, which is because I'm just going to plug them into the board. I did it because I'm lazy, but you miss out on doing the electrical checks to make sure that everything is wired up correctly if you do that. So I don't recommend it long term, but for a small kit, that's fine. So I got everything wired up. It matches the way my board works. I know it all works. In practice, I actually go back and forth a few times as I play with these things because, of course, I wanted to draw the board before I tested all my stuff. So then comes my least favorite part of the process, which is getting footprints. So before I can put the things on the board, I need to know how big they are and where the connectors go. And you would think this would be pretty easy. I just search a part number and I get it. Yeah, no. Part numbers are random gobbledygook strings. Half the time, the one you want isn't in there because it's similar to something else, so nobody ever made it. And thankfully, the maker community and the open source community have a pretty big overlap, so often you can just search on GitHub and find out that someone else has made it, but sometimes you're going to have to make it yourself. So I figured that all out, and then I import my picture in, and you can see actually that I had to convert it to be red and black because when I did the black and white only, it had a background problem that didn't work so well. And actually, I don't even know what color this thing is going to be in the end because I haven't decided yet. So I pull it in there, I grab my components, they're initially laid out more like my circuit diagram, I move them around, and there we go. You can see that it's just got straight lines saying, now you need to do some wiring. So I do some wiring, and it doesn't look good. So I don't know how well you can see, but that's a pretty strange thing that I've let the auto router do for me. And you'll note that there's wires hanging off the edge. That's not going to work. Oh, right, I forgot. I need to put the edge cuts in to show where the edge of the board is, because otherwise it'll do stuff like that. And you can see This is I really like the 3D rendering tool that comes with it because it allows you to see whether you've made really stupid mistakes. You can see here that it's assuming I have a square board because I haven't told it otherwise. And you can see that I helpfully put the battery pack on the front, which is not really going to work for my aesthetic. So I was all prepared to get up here and tell you a long story about shaping boards and making it work and how hard it is and how you have to convert to bitmap. But actually, I did this and it just worked. So you make a nice outline. I use Inkscape. I love Inkscape. You can export as the Adobe style DXF, but not the other style DXF. And it should be able to import. And so there you go. You can see, well, my traces are still falling off the edge. But you import it in as the edge cut layer. Sometime later, I have finessed my stupid wires to be better. They're still not great. I'm probably going to tweak it a few more times before I actually order, just because I'm picky. So the next step, once you've got it working and you've run the electrical tests, would be to order it. There's a bazillion different places you can order PCBs from. I usually use PCBWay because they sponsor the Maker Faire, so they do it for us for free, and they're totally awesome. If you're local here and you're doing a really small run of something, the folk at Osh Park are really great to work with, too. So, some tips. Number 1, start early. This is a picture of a typhoon in Taiwan. And when I got married, we decided we were going to do little soldering kits as wedding favors because we're nerds. And there was a typhoon. They arrived a day after the wedding. So if you want one, I've got a few extra boards here. I don't have them all kitted up. And I was planning to tell that story because, of course, that's an older story. But, of course, this time I forgot about Chinese New Year, and then the coronavirus happened. And it's much more important that everyone is safe in those factories than that they produce my crap. So I do not have my first prototypes today, but I will soon. Number 2, test with actual hardware. So I showed you doing that. The reason I know to do this is the CloudSun board. We discovered that we had gotten 2 lots of Node MCUs, and some of them work perfectly, and some of them, if you push, I forget whether it's the right or left button, but if you push one of the buttons, the entire board reboots, and that's not really a very satisfying experience. So yeah, the next version of this does not have quite as many buttons. And then the version after that, we found out that we could get the screen for way cheaper, which is great, but they reversed ground and power, so we had to redesign again. Number 3, buy extras and prepare for failure. I am lucky that I have a box of Node MCUs in the basement because otherwise I would have redesigned that entire board to use 4 LEDs instead of 6. And it's especially important for things that are soldering kits because if you're expecting people, especially children, well, okay, especially adults, the children are great at this. Especially adults, sometimes they're going to let the magic smoke out and burn apart, and it's much more satisfying if you can just say, here, I got another one for you. So the last part of the story is that, okay, it's awesome that we're building these soldering kits and the people who come to the Maker Faire have more fun things to do, but it's actually cooler than that. We actually use this to help sponsor the Maker Faire and make sure that it's sustainable. So I'm lucky enough, I work for Intel. They do a time match for any of the time that I spend on these things. So they give $10 an hour for all of my volunteer time designing this kit and figuring it all out. And then on top of that, we donate the parts because we didn't want the Maker Faire to have to deal with us figuring out when to order things. And so we just order them all, and we donate them, and then our companies match that again. My husband's company also does a donation match. We only, one or the other claims the parts, but we can both donate time. And then once we've done all that, so the Maker Faire has now gotten these kits for free. They've gotten the boards for free from the fine folk at PCBWay. They've gotten some extra money for our time and for the donation that comes out. It comes later, but then they get to sell the kits. So we basically sort of 3 or 4 times our donation, and as a result, we accidentally became one of the major sponsors of the Albuquerque Maker Fair by the final amount of money that is donated every year as we restock kits. So yeah, I'm pretty pleased with that. So I've got a complete, I debated whether I should carefully clean up my repo. It's not. You can see all of the terrible things I did in routing in order to make pretty slides. But there it all is. Have fun. And before I finish, I'm going to plug in one thing. We're going to do a little live demo. I'm not a big fan of live demos. In fact, I hate them. But I built a decibel meter. I'd like you to applaud. Thank you, everyone.
People hear me? All right, so thank you, Terry. That was great. We're going to have about a 10-minute break, and then at 10:20, we will learn about web scraping. Thanks a lot. right, welcome back. Now we have Julia Piaskowski who's going to talk to us about web scraping.
Here is the GitHub repo where it's located. The slides, if you'd like to follow along right now. Unfortunately, you do have to download them as how many people, just a show by shouting, if I can barely see you, have done any web scraping projects? Whoa, okay, nice, that's great. This was my first web scraping project. Okay, a great way to learn Python and learn web scraping is this book, Web Scraping with Python. Of course, I cut off the author's name, but you can find that on Amazon. But realistically, who's reading these? I mean, I'm not. This is me with my programming books, just like Luke throwing away a skyscraper. I'll get to that later. So the main things to know in a web scraping project, this is also my talk outline, is when to know when web scraping is worth the trouble. Because it is a pain. This is called Adventures in Babysitting, a movie about a babysitter where pretty much everything goes wrong that night. And that's what web scraping is like. It just takes a lot of patience and attention. Is it ethical and legal? The tools available in Beautiful Soup and requests. What you're actually looking for in HTML code, that can be one of the hardest parts. I found that knowing skills in how to parse out Johnson objects, as well as just rudimentary Panda skills, which you kind of need to do almost anything in Python if you are a data scientist. Coming in, I knew not a lot about HTML, and something I found was that everything operates in these tags. So this is my pro tip from not a pro, an amateur tip. What's encased in the angular brackets is the tag name, and then all you need to know about HTML is how tags work, is what would be captured by that tag if you were to search on that, and then ends at that / pro tip. And so just knowing that is how HTML works, is you access tags and by their name, and then you can get the information inside. It was really helpful. So, what to look for in a web scraping project? It needs to be a sizable amount of data that's, of course, not worth the trouble of you to manually collect it, or myself to manually collect it. And it's best if it occurs in a very regular and repeated structure, sort of like all these cosplay Spider-Men. And the more edge cases, the more variations on that repeated format, just simply the more complicated the scraping will be. Of course, if you've done any programming, you know the edge cases are like 0.5% of the total cases, and they're about 50% of your time. It can be really annoying. Okay, ethics and legalities in scraping. Of course, it can make you feel very powerful, make me feel very powerful. I can access all this information. Wow. I'm as powerful as Captain Marvel and her photon blast. But, of course, just because it can be done doesn't mean that it should be done. I'm not a lawyer. This isn't legal advice. This is just some things I came up with. I also put a couple of articles that were legal reviews inside that GitHub repo addressing this topic. But it's worth at least considering, is the material copyrighted? Will the scraping compromise an individual's privacy, or many, many individuals' privacy? Is the scraping, so intense that it, looks like a DDoS attack on a server that may take it down? Can you expose intellectual property? Or most importantly, are there terms of service governing a website? Say, you authenticated into a password-protected site. And will scraping activities diminish the value of the original data? Something I like to do with scraping is get the data and do something new with it, not just get it and disseminate in a way that's no different than how it was originally available. So the example I wanted to walk through is Family Dollars. They're taking over the world, over the U.S. Here's a picture of a store in Cascade, Idaho. I don't live in Cascade. I live several hundred miles north of that. And They actually provide food in a lot of rural areas at the expense of local grocery stores. So people buy their food there, and then grocery stores often go out of business, and because Family Dollars are very affordable, and yet they don't offer any fresh produce. So I wanted to extract all addresses for all the family stores in Idaho, and actually across the U.S. So starting point was this URL, locations.familydollar.com/ID. And of course, I'm sorry, it's very difficult to see for especially people in the back, but even people in the front, I'm suspecting most of that's unreadable. This is a list of cities in Idaho where there's Family Dollars, and you can click on that on any of those cities, which is a URL leading to a list of stores and their addresses. So there's a lot of them. How do we get it? Or how do I get it? So start by loading the libraries. The main libraries I used, or the only libraries, were requests for requesting that information from requesting the data off of a URL. Beautiful Soup, probably a lot of people have heard of that. That's this pretty magical module for parsing HTML content. It does a really great job with that. JSON, a lot of data coming off of websites is in a JSON format that, while intimidating to work with at first, was incredibly handy. And then, of course, just any kind of rudimentary skills in just being able to use Panda is helpful. So, and I just imported DataFrame. And then the second step was to get data using requests.get and simply feeding it the URL. And then that grabbed all of the content in a pretty unordered fashion. And then the next step is to do page.text, extract the text, and then use some sort of parser off of Beautiful Soup to parse out that complex HTML or XML tree of data. There's other parsers out there, and I tried a few of them, and HTML.parser is really effective. It's the default one. I didn't see a need in using other ones, but I'm interested to hear if people have had other experiences with other parsers that worked for them. And then that gets transformed in this complex tree that can then be navigated, via Beautiful Soup. And so there's 4 main objects I found myself working with. One was just soup, that's just everything, all of the content. Tags within the soup, that's the main type of what they call a BS4 element. Strings within that, a navigable string, and then a comment, a special type of string. But most of the time, I found myself working with soup and then a tag in that soup. If you can avoid working with strings and regular expressions, well, I'm a lot happier if I don't have to do that. Okay, so once you get that content, you have to parse it out, and oh my God, that is so frustrating. That can make you crazy. Just patience. Don't do what this guy did and throw a fit and break really expensive equipment that doesn't exist in our world. Okay, so finding content. One of the easiest ways is to just start with a representative example and then scale up, because I found I failed a lot, so I didn't want to be waiting a long time to find out I failed. The best way is, of course, to view the web page's HTML source code. Now, every Beautiful Soup tutorial I looked at had this print soup.prettify, and you'd run that on the soup and it'd print it out, which works on the tutorial. They're toy examples, but if you try to do that on an actual example, man, I regretted that. I'd never do that again. It's just a outstanding quantity of output that will show up. Ran this in Jupyter, for the interactive nature of Jupyter. It's just an outstanding quantity of content that can't even be really looked at. So there's better ways to do that. And one is to just be at the website, right-click, view page source, and then you can see it. Of course, here's another image you guys can't see. That is from the website that I visited earlier, the familydollar.com/location/ID. And these are locations for some cities in Idaho: Aberdeen, American Falls, Arco. And what I'm looking for in that is what attribute and tags that are attached to the content I want, I can use to extract that content. And so what I wanted out of this page was the hrefs, the hyperlinks to where these stores are. And there's an href equals, and then the link, and then above that was a div, and then class equals item list. So there's the class equals item list, and then there's the hrefs. I thought, well, that could work. And so the find _ all, very handy function within Beautiful Soup to search through the content and find every example. Well, I tried searching for that attribute href, and nothing. There was no results. Oh, drat. But then next tried searching under the class equals item list, and it's actually class _ equals item list. Class is a reserved word in Python, so you have to use this class _. So don't make that mistake that I did. And that worked. And of course, I'm summarizing a lot of trial and error that making it sound easy. And then one thing I do is always just check it. So I printed the first two, and that got cut off here, but it did work. It extracted at least the content. It's a bit still unordered, and out of that, I would still like the hyperlinks. And so it's helpful to know what kind of content is it, how much is there. It's a BS4 element result set, and there's 48 items in that. So hopefully that indicates 48 different stores, or at least links to cities, or in 48 different cities. But I look at a single represented example, looked at number 2, that's Arco, Idaho, this really funky place in southeastern Idaho for a city powered by nuclear reactor. It's pretty quintessentially Idaho. And extracted that with contents. Contents is just this amazing function in Beautiful Soup that will grab your content and parse it out in a way that you can navigate it. It returns it as a list of a single item, and so often the first thing that has to be done is indexing that first item. So that's what I did, example.contents, and indexed that first item, and then looked at the ATTRS, the attributes. Then here it is, there's 2 attributes, href, finally, and DTA/link track. And that can just be grabbed using, so again, it's example.contents, indexing that first item, and then just calling the href in brackets. And alas, at the bottom of the slide, there it is, finally, 1 HTML address. Okay, made it through one part. Got 1 HTML address, or at least the beginnings. And so the last step is to just put it all together. I'm sure there's faster ways to do this. That talk on coroutines was amazing yesterday, and that gave me some ideas. But this is just a loop and a list, and it and it's at the very least, grabbed about one on my laptop, about one address or 1 href per second. So it's a slow way to request sites from the Family Dollar website and hopefully not annoy them. I just went through the list and grabbed the contents, indexed the href, and then appended that to this empty list city _refs, and then double checked it, and yay, have what I wanted, sort of. Now I have a list of URLs of other Family Dollars. Now I got to scrape that. Okay. So, do it all over again. Start with, again, a representative example, this Arco, and start getting that, and then parsing that text out using the same process. And again, I still have to visit the website, though, and have a look. And here on the left, what's actually displayed, I can see the Family Dollar, can see the address, or I can see the store, the address, and looks like its phone number and a map. And then on the right, that's the right-click inspect element, slightly different from page source. I can see that content. Of course, you guys can't, but what's highlighted is the address. And above that is type equals application/LD plus JSON. Having scraped many drugstores and dollar stores, I found that this is a common type for addresses. So wanted to search on that, type equals application / LD plus JSON. And that was a successful find all command, and then printed one out, and it looked pretty nice. Extracting this and getting out what I wanted was one of the one of the more frustrating parts, when I thought I might throw my computer out a window, but I did not. And first off, I found out the address was actually the first item, or sorry, the second item in the list and not the first. So I'm not showing you guys my trial and error, just showing you the end, and that indexed the contents. Again, indexed the first item, extracted the contents from that, and then basically delisted it by indexing the first item. And then the contents are there. It's been cut off with the address, with lots of other extra information, including tabs and carriage returns. It was clear it was a JSON object that it said JSON in the object type back there, LD plus JSON. So I converted to a JSON object using JSON.loads. And JSON objects are pretty fantastic. How many people have worked with JSON objects? Again, shout. Oh, wow. Yay. That's nice. I gave this talk twice in preparation for this, and I hit 2 audiences that had not. So, great. Although it's nothing wrong if you don't know anything about it, it's a handy format to work with. It seems complex, but it's really just a dictionary. It's, a key and a value. And then it can have some nested keys and values within that. And so the key I was looking for under print on Marco Johnson was this address. I wish I had a pointer. Alas, I do not. At least not a pointer anyone can actually see. And so once that was converted to a dictionary, then I could just index address, and that's located on the second line of this output, and that's where I would get it. And so, alas, it worked. Yay, finally. A lot of trial and error up to this point. I was very excited. So, again, my representative example worked, so loop it all together, request that information across all of those different cities, parse it out, search for the application type, get that information you use. I'm using contents, convert it to JSON, index the address, and then append that back to the, initially what was an empty list. And then lots of information's out. Finalizing the data is not too terribly difficult. There's this amazing commands from _records that will convert a JSON dictionary into just a standard data frame, and I dropped a couple columns that weren't needed at type and address country, and then here are the top 5 values that came out of that, and formatted exactly as I would like. I was very happy about that. So yeah, after there was a lot of I'm struggling. This is my single gift from Adventures in Babysitting, in which, everything goes wrong, but at the end of the night, she does get the kids home safely. Of course, it's important I write out my data to file and not celebrate too hard, but actually make sure I saved it. So, wanted to say a few words on Selenium. Presumably, a lot of people have heard of that. It's a very popular application for web scraping. It is a pain. It's got a lot of overhead to learn how to use, so it's not always worth the trouble. So this is when I found I needed it, was when I was doing the same process, except in a Walgreens website. So this is the store listings in Oregon. That's what the URL is, walgreens.com, and then a set of extensions for looking at those listings in Oregon. And then here's one for Portland. And then on the right, when I clicked inspect element, I could see Portland, and then I could see an href for that, so I could link to it, and then go and extract the address from there. Like, And then that was, again, class equals call /XL or -XL-4, call -LG-4, call -MD-4. I don't know what that means. That's the weirdest class, but, that's HTML for you. And, but when I searched on that, like, nothing came up again and again. Like, what went wrong? What went wrong? I don't understand. And then I did a view the page source, which is the actual code that the request command will obtain. And first of all, it was massive. It was just huge. Most of it was extremely incomprehensible. And when I did a search on Portland, that's what that pink box is on the bottom left, like nothing came up at all whatsoever. So it took me a while to realize there's plugins, some JavaScript, maybe some Python that's modifying the source code as it loads. So this page needs to be accessed after it's loaded into a browser. And so that's when Selenium comes in, is that it uses a WebDriver to retrieve the content. If you run it on your laptop, it will actually open a browser with some fancy sign under it that says something like, this is being controlled by a robot. And then that is the information that's collected. It's really powerful, can interact with content in lots of amazing ways. It can click on buttons, it can authenticate, it can go back and forward and just navigate through an entire site. So I started with this URL for Walgreens, again in Idaho, instead of Oregon, and used a WebDriver that was specific to my browser, in this case Firefox. And you tell it where it's located on your computer. Then use driver.get to open that URL and get that data. And then once that page is loaded, then Beautiful Soup, the page is loaded and the information collected. Then Beautiful Soup can be used as it was, but before, to parse that data out. Again, using HTML parser. So when I did a find_all on that bizarre class, which was probably generated by a content management system, it was very successful. So, okay, so second to last slide. It's just helpful to read the manuals. I've given you kind of my top 10 things that worked for me, but there's a tremendous level of functionality available in Beautiful Soup, and it always helps to read through those manuals to some extent. If they're definitely a new user, will likely have to consult the Selenium documentation, as it's complicated. It's not that easy to set up. Again, this is the link I gave earlier, but it's on my GitHub repo, along with a more full example. I've kind of put up a toy example, but I did a full one for going through all of the Family Dollars in the United States. And it's just first initial, last name. So my name, I realize my last name is a bit unwieldy. It is in the schedule. And so just, the lesson is to persevere and be really patient. And this will be you guys after you become masters. This is me now. And, my bonus slide, not my penultimate slide. What I found out, there's a lot of dollar stores. And there's almost 8,000. There's actually none in Washington or Oregon. That was a shock. And they're most certainly not randomly located. How that correlates with things like poverty level and food deserts, average income, I have not sorted that out yet, but I'm curious to do so. Okay, thank you guys.
Julia, we'll be back in about 10 minutes at 10:55 to learn about simplifying Docker development with Python. Thank you. right, hello again. Now we're going to learn all about how to easily develop with Python and Docker. Please welcome Caleb Elwert.
Thank you. All right. Hello, everyone. I'm Caleb Elwert. I'm a software engineer at the Pokemon Company International, and as he said, I'm going to be talking about using the same Docker container for both deployment and development, as opposed to separate ones for each or only handling one or the other. For fun and profit. All right, so I'm going to go through a quick overview. These are the things we're going to cover. We're going to go over basics. What is Docker? Make sure we're on the same page. Get some basic terminology down. A refresher on the 12-factor app setup, which is guidelines for building web apps for scalability and maintainability. Some best practices for settings. Everyone's favorite exciting topic. Best practices for settings, how to make that work well with Docker. Then that far into the presentation, we'll actually get around to running the application inside Docker. We'll go through, build a Docker container kind of from scratch and show some of the mistakes you can make along the way. And then eventually we'll get back to easier development because there are a lot of pieces here. We want to make sure they all fit well together. All right, what is Docker? Also, fun fact, that whale, I'm sorry, his name is Molly. I didn't know this until I had to give this talk. Fun fact. So, Docker is a wrapper around a number of Linux kernel features. This is at a very high level. Docker doesn't really do a whole lot of special things by itself. It just pulls together a bunch of other features. It's a lightweight system for running containers. So instead of running like a full VM where you have to run your operating system, it's a slightly more lightweight way of doing things. And then it's a tool for orchestrating containers. So we can tie a bunch of containers together. You can run your database container really easily. You can run your web application. You could potentially run Celery in another container, however you want to do that. If you're not as familiar with Docker, there's a fantastic talk by Lacey Williams Henschel on Docker in Harry Potter terms. It's great. If you haven't seen it, I would strongly recommend it. I'm going to be going a little bit past that, assuming you have kind of basic knowledge, but we're going to cover a lot of similar things and some different things as well. So why Docker? It's lighter than VMs. This is great. So VMs are kind of heavyweight. They take a lot of memory. You can't run a lot of them. It's hard to spin up like 5 new VMs, but it's a lot easier to spin up 5 new containers. You can separate your dependencies from code. This is really nice because you can ship a container, and on a similar note, it mostly removes the "it works on my machine" argument. I cannot tell you how many times I've heard this, but it's great because if it runs on your machine, there is a really good chance it runs on their machine as well because it's all running inside the container with everything sort of encapsulated. Uses a standard container format, and because of this, it's pretty easy to deploy. There's Kubernetes, and then Amazon has ECS, Google has a solution, and I believe Azure also has a solution. Where you can basically just say, run this container, I want it behind a load balancer. If it gets hit too much, spin up more. So important concepts. These are, I guess, sort of base level knowledge that we'll need when working with Docker. We have an image. It is a prepackaged bundle. So it includes source code, dependencies, hopefully everything you need to run your application, aside from like external links to like your database. You have containers, which is a runnable instance of an image. And then there's the Docker file, which is your set of instructions on how to build an image. It's like a make file on steroids. And then you have OverlayFS. This is a generalized generalized term for the system Docker uses to store its file system changes, but it does it in layers, which this is important to note because as we'll get into later, if you make some, I guess, easy to make mistakes in your Docker file, you could end up with an image that's like multiple gigabytes big, and it only needs to be really tiny. And then Docker, which is client and service for running those images as containers. There's also Docker Compose, which we'll get into later, which is sort of a tool that I like using for local development, for pulling a whole bunch of containers together, linking them up, making it so you don't need to do a whole lot of extra work. Important commands. We have Docker image build -t. The -t isn't necessary. That just lets you tag it. Otherwise, it'll come up with a random string of characters, which is not exactly the most user-friendly thing in the world. Docker container run, and then the image name. That can be, as I said, either a random string of characters or the tag that you gave it. And there's Docker PS, which lists the currently running containers. So now that we're on the same page, we've covered kind of basics on like Docker, made sure same terminology. We're going to jump back into the 12-factor app. It's a set of guidelines. I'm not going to say they're rules. Barbosa would agree with me. Yes, guidelines, not rules. For building web apps, it's a methodology aiming to make a number of things easier. CI should be easier, scalability should be easier, and you have shared code between production and deployment. I'm just going to jump through these because there are 12 of them. But the one we're actually looking at most of them. So dependencies, as I mentioned before, configuration in the environment, attached backing services as attached resources, make it possible to build and run. You can execute the app as one or more stateless processes. You can expose services via port binding, so like you just expose a port and everything works. And to scale it out, you basically just spin up more instances. Most of these aren't, let's see. The other one I'll point out here is dev prod parity. That is kind of what this talk is about. That's what we're focusing on. So those are the 12 factors at a very high level. The Docker makes about 8 of them really easy. If you do things right, you can handle 8 of the 10, and then the other ones you can build on top of it. I forgot the link, but if you want more information on that, like super in-depth on a lot of those, there's a website, 12factor, 12factor.net. That's the numbers, not spelled out. So best practices for settings. Then, again, everyone's favorite topic. Let's talk about how to configure your application. So we want to make sure that secrets, anything from your Django secret key all the way to like API keys, anything you want to make sure all of those are in settings. You don't want to be committing those to your code base. We have a DevOps team and a security team. They would probably find me at my desk and murder me if I did either of those things. You want to avoid having multiple settings files for different environments. Our legacy stack, which is my favorite thing, as it always is, has a development settings file and a prod settings file, and all of these import from a magical file called machine local, which is local overrides that are just dumped into the environment. That's not great. We don't want to have to do that. We want to default the settings that won't break production if someone forgets to set them. We don't want debug to be on by default. We don't want to like open us up to CORS vulnerabilities, any sorts of things. We don't want to break production. And then we want to load from environment variables where possible. So environment config. This is a basic example on how to do it. You can start with. Okay, this has been kind of frustrating me. The string to bool there is nothing in the standard library other than this for easily converting a string to a bool. This is good if you're not using Django because you can do whatever you want. If you're just using os.environ, you can pull from whatever environment variables you want. You can set defaults because it's just a dict. But they're very useful things. There's a package. as there always is, called Django Environ, which is a convenient way to configure settings via environment variables. It's got tools for loading database configs, cache settings, email settings, all in like a single environment variable, without you having to parse out all of the small parts and make sure everything is right. It also has helpers for building paths. So if you have like paths relative to the application root, you can easily build them with this. I don't use that as often. It's mostly the other tools, but it exists. This is similar to the previous example, but as you can see, it's a lot cleaner. We don't need to convert between a whole bunch of different formats, coerce stuff into strings. It's a lot easier. You can set defaults, and you can even do things like lists. So those are 3 examples of things that we would want to set. There are more. There's a whole running Django apps in production guide that I would recommend you go over. Those are 3 examples. Databases are super easy. There's a DB URL included in Django Environ, which lets you just give a database URL. So then you'd say, just like accessing any resource. It would be like Postgres, and then you'd have your username, password. Everything goes in this one string. So you can expose everything through one string rather than worrying about, oh, I forgot to configure the password. So anyway, it's all there. Caches are pretty much the same thing. It covers all the officially supported cache drivers and some third-party Redis packages. There are some other useful things. And then you get the drill by this point. Email's a little bit of an oddity, but the Django Environ GitHub page has a whole bunch of examples. It covers everything. So all of these are tools that we can use to make our application super easy to configure so everything's in environment variables, which will make it easier to spin up, everything else. All right. Now we get to the fun part. If you remember, this talk is about Docker. We haven't really talked about it much, but we're getting there. So we're going to start building an application to run in Docker. We want this image to have all of the dependencies in line with the 12-factor app. And we want the same image in production and development. That was one of my main reasons for doing this talk, is I've found a lot of really good solid tutorials on building a container for development or building a container for production, but not one where all of the code is shared between them. This is something that it reduces errors because it means if you can run it locally, you can run a version in production. So Docker workflow is you write a Docker file to describe the dependencies. You're going to install everything from your requirements.txt or however you do it. We're going to use Docker image build, as we mentioned before, to build an image from that Docker file. And then you'll use Docker container run to create a running container from that image. These are the same commands that we mentioned before. So version 1. Okay. This is version 1. Okay, so we start from Python 3.8. I use the slim images. You can use just the normal 3.8. The one thing I wouldn't recommend doing is using the Alpine images. You can get something smaller, but it also, without a bunch of additional tweaks, it won't install the wheels, your Python wheels. So things are very slow to install if they have compiled code. In particular, the example that was given was, I believe, NumPy and Pandas, which take upwards of 30 to 40 minutes to compile, and that's not something you want to be adding to your CI. So we start from that image. If you remember, at the very beginning, we talked about overlay FS and how everything is built on layers. So the Python 3.8 image that we're building off of is sort of the first layer. And then every command we add after that will add another layer to this image. So our first step, we're going to install Django. We're going to change to a directory code so we know where everything is, and copy all of the files into the image. You can use command like that to specify the default command to run. There's also entry point, but in general, you probably don't need to use that. And then we tell Docker that we're running something on port 8000, and it should know about that. There's lots of room for improvement here. It uses run server, which is not production ready. We pin Django, but that's about it. We don't. So everything is dependent on what's in the Docker file, and we want to have that somewhere else. And then we've got some additional optimizations that we can make. I mentioned earlier how OverlayFS, there are some pitfalls. We'll cover those. And then some extra Python tweaks for Docker. There are a bunch of random environment variables you can set that a lot of people don't know about. So, add a WSGI server. This looks almost identical to the previous one, except we're using Gunicorn instead of run server. We'll deal with this later when we actually set up a development environment. So we're not running Gunicorn when we're developing, because then if you're using Gunicorn, you lose all sorts of like live reloading, debugger, things like that. Pin dependencies. This is pretty much the same thing. I have an additional step in there to make sure we install the Postgres libraries so we can actually build the Postgres dependency. All right, this gets bigger. I believe I split this out into multiple slides, but as you can see, we're still starting from the same Python image. We're still using work directory to make sure we're in there, but we only copy in the requirements.txt file. This may seem strange. We need all our code. But one optimization Docker does is if you copy in some of the files, it will only run all of the steps after that if those files have changed. Because we don't want to run this magical apt-get, pip install, all of those every single time. It's not the fastest thing. So we copy in the requirements file, and then we do the step that depends on it. We install the dependencies. I guess I covered that. One other oddity is you'll notice there is a single run command with about seven subcommands on that. That's an optimization that you can do. Because if you remember, every single time we put something in our Docker file, it will create a new layer. So if we had all of those in separate run commands, it would create new layers. And because at the very end, we remove the development versions of the packages, it doesn't matter. If you added files in a previous layer, and then in a later layer removed them, the image is still going to be as big as it was at its largest point, because all of these layers have to be built on top of each other. So we do all of these in one command. We install the dev dependencies, install the requirements, remove the dev dependencies, and then we remove everything. We remove basically a cache that apt uses, aptitude dpackage. Python tweaks. These are fun. Random environment variables. I love these. So Python unbuffered, I ran into this once a long time ago. We were trying to deploy our application, and we're like, why aren't the logs spitting out? It turns out if Python isn't attached to a TTY, it will buffer its output even more than it already does. So it doesn't do it per line. It could buffer like 4K of output and then dump that all at once. Python unbuffered tells it not to do that. So if you use the docker log command, it will actually display useful information. Python don't write bytecode. I feel like I would be disowned if I didn't put that in here. It's just sort of a conference requirement. Python hashseed is an oddity, and it also isn't really necessary after Python 3.2.3. I don't know why that happened in a patch version, but I'll take it. This ensures that hashing uses a random seed rather than predefined. This makes things slightly more secure. It's why they turned it on by default. And then we stop pip from saving files it doesn't need. That's the no cacher. That will make the final image smaller. And then we disable the pip version check because why not? We don't need an extra network call. Okay. After all this, we have a Docker file. We can build an image. We can run that as a container. So that's not exactly the easiest thing. So let's talk about making it easier for development. We're going to get back live reloading. If you remember, we replaced our server with Gunicorn. We're going to automatically spin up a database. This is something that is pretty hard to do it's pretty hard to if you need to nuke the database to test a migration, things like that. Very hard to do. It's really easy with Docker. We're going to automatically spin up a cache similar to the database so we can test closer to our production environment. And we're going to spin up another container that lets us see what emails are sent rather than just using the console mail log. So if Docker Compose is the engine or if Docker is the cargo ship for running containers, Docker Compose is the tool for orchestrating them. So that was like a crane or this adorable picture of an octopus, though a kraken wouldn't be very helpful in running containers. Important commands is part 2. These are Docker Compose commands. They're pretty simple. You have Docker Compose up, which will run all of the services specified in your Docker Compose file. And then you have Docker Compose down, which will stop all the containers related to the current directory's Docker Compose file. So these are 2 very simple commands. You build up your development environment, you tear it down. And then run --rm command. This makes it really easy, so you can spin up an entire set. You can spin up all of your containers. You can spin up Postgres, caching, and still run a separate command. So if you use this and then, as an example, ran manage.pytest, you would have a full Postgres instance you were testing against. You would have a full cache instance that you were testing against, and you don't need to do a whole bunch of extra stuff. Version 1. This is a little bit overwhelming, but we're defining one service in here. This is just our Django service. We're going to tell it to build from the current directory, and that's pretty much it. But we're going to override the command. We can do this, and this lets us get back run server. So we can still use run server to get live reloading. But if we forget this, if we forget to override the command, like in production, we're still going to be running Gunicorn. And then another little trick is at the bottom. You can mount the current directory into your Docker container as the code directory. This is another thing that we need to do to get live reloading back. So now we're going to add Postgres. The top block looks pretty similar. We just changed the database URL. That database URL is really similar to that database URL is a thing that we mentioned before that's handled by Django Environ. We can, I believe, SQL Alchemy automatically loads stuff from URLs, so that's really easy to do as well. And then we specify that the container depends on Postgres. So it'll wait for the Postgres container to spin up before actually running our Django container. Add memcache. It's the exact same thing. We give it a cache URL. We tell it to run memcache as a service, and it just does it. Then we have Mailhog. This is a tool that I found. It's not quite as standard, and it's really only useful for development. But this gives you a nice web interface for if you send email, you'll be able to look at it as if it's an actual email and not just text. Very helpful for debugging. So I realized that was a lot of stuff to cover. But we covered what is Docker. We covered the overview on the 12-factor app, best practices for settings. We built a Docker file very quickly, and we got back most of the tools that we have for easier development. This is also in Lacey's talk. Docker is used everywhere. It's like just jamming pieces together you don't necessarily understand. I hope that some of that has been alleviated by this talk. But there's also, we're going to see how this goes. I will probably regret it. I have all these ready. There's a repository. That looks great. Maybe we won't do that. There's a repository that has the Docker files. It has the basic Django tutorial with the polls app, and it goes through. It converts all of this stuff to run in Docker at that link. So thank you for listening. If you have any questions, I will be around for probably a little bit longer. You can always, I don't know, I guess file an issue on the repository if that's open. Thank you.
Thank you.
All right, thank you, Caleb. That was great. We have a break right now, and we will return at, looks like 11:35 for our next talk on CPython internals. See you then. now we have Moshe Zada, who's going to talk to us about interpreting Python bytecodes. Mike.
Hi, everybody. How are you all doing? Yeah, cool. The second day of the conference, still lots of energy. Awesome. Right. So I want to start by talking a little bit about how I suggested this talk. So like maybe it will be a fun talk to do, like a little bit about how Python actually works under the covers. The eval loop is always a fun topic. I'll talk about that. Then I decided because I like a little bit of a play on words. Who's afraid of the big bad loop? Sounds like a fun thing. So I submitted it and I wrote a description. And then they accepted it, which, great. Right now I have to actually write the talk. So I opened like the ceval.c, and the last time I looked at it was like probably like 15 years ago. And then I realized that the answer to the question, who's afraid of the big bad ceval loop, is me. Because like I literally recognize like almost nothing of it. But I figured how things are going, and today I'm gonna tell you a little bit about the things I figured out. So as I said, my name is Moshe Zadka. This is a link to the website. It has all the links to my social media, my Twitter, and everything. So if you want to follow me on anything, you can go there. Okay, so before we go into the eval loop, you think about it, this is the internal of Python. The internal of Python have a lot of other parts. So what am I not going to talk about? So let's be clear. Okay, so you write your Python source code. That's fine, but Python, like the Python interpreter, actually looks at your source code. You have a parser. The parser turns it into the AST. The interpreter does not look at your AST either. The byte compiler takes the AST and makes it into the bytecode. The bytecode is what you actually give the interpreter. So you might think, well, this is where like all the semantics of Python are. Well, not really, right? The bytecode interpreter mostly ends up calling methods on Python objects. A lot of Python objects are built in, right? Like, what does it mean to add two integers? It's actually complicated, right? Because Python does big num stuff and promotion. What does it mean to add strings, right? You literally have to allocate a room and do all kind of stuff. So all these stuff is also not in the eval loop. That's in the object semantics, right? Those are in the internal built-in objects. So all these things are things I'm not going to talk about. Okay, so like, and this is important because a lot of the semantics of Python are in those parts that I'm not going to talk about. So this is kind of important to mention that even after you understood everything about the talk, not everything about Python will be obvious. So what is the eval loop? So as you kind of think, this is a loop, right? The way to spell an infinite loop in C is for colons. There are other ways, and this is the most efficient way, and this is why Python does that. And none of the code you actually see here is actually in the C Python interpreter, right? This is all a lie. And this is actually kind of important, right? So this talk will mostly be consisting of lies. I'm going to lie to you pretty much every slide. The slides with Python codes are pretty honest. All the slides with C code are going to be bold-faced lies. But there's a good reason why I'm going to lie to you. The C Python interpreter runs your bytecode. Now you're pretty happy that it runs your bytecode pretty fast. You might be complaining that it runs your bytecode pretty slow. But a lot of effort has been done to make it as fast as possible. Unfortunately, the way to make code as fast as possible is to make it really hard to understand. If I showed you honest code, the actual code from the interpreter, it would be really hard to explain it. So instead, I basically removed a lot of the optimizations, manually undressed some macros and kind of like some weird optimizations that are kind of not interesting to understand semantics. So every bit of single C code will be a lie. Which is why like much of that C code will not properly compile or will even properly parse, but it will get the right idea, of course, of like what is it trying to do. So when you actually, if you end up reading the C code, you'll see what it's trying to do, and then you'll see what it is actually doing, and you have like a way to match it up. So yes, most of this talk is lies, but like I said, not the slides with Python on them. Those slides are pretty honest. So the bytecode interpreter, as you can imagine, it interprets code, right? This is pretty straightforward. One of the ways we find code in the wild in Python, right? You can even access it from the Python layer, you don't have to go to the C layer, is when you have a function, it has a code object on it, right? So this is a code object, but this is a very simple function, right? It literally just returns none, so it does really nothing interesting. So if you want to look at like an interesting code object to figure out what a bytecode actually looks like, let's have a function that is still a pretty simple function, probably simpler than like all the functions you all have written, right? This function just returns a plus b. And as you can see on the code, there is a byte object called cocode, right? This is great because we talked about byte code, right? This is bytes that are code. Awesome, right? So it's actually like a good name, right? So this is a byte object. And let's kind of look at the byte object a little bit, kind of like let's meditate on that. Right, so the first byte is a pipe byte. Then there's a null byte. Then another pipe byte. Then the byte 01. Then a 17-byte null byte. S byte, 0 byte, right? So you'll notice that they kind of come in pairs, right? It's always a byte, and then either 0 or 1, and kind of like 0 seems to be most popular. And this is actually like, even if you write a pretty long function, it will mostly look like that. And the reason is because internally the bytecode is actually made of that, right? It's always pairs, right? It might be the other order if you do it on a real machine, but it's always in pairs, right? And on kind of like, I guess, modern Intel-based machines, it will be the opcode first and the argument second. Now, a lot of opcodes do not need an argument, right? For example, return value is just return value. So when it doesn't need an argument, it still wants something in that place. And part of that reason is efficiency, right? It always knows that it has to get 2 bytes. The first one will be the opcode. The second one will be the argument. Now, looking at those bytes and remember what they're meaning is kind of hard. So this module basically kind of turns the bytecode into an assembly language for Python. It's really useful, by the way, if you actually have a complicated function, you want to say how Python sees that function. This is how Python sees your source code. Right? At the point you give it to the interpreter, it doesn't see the a plus b. What it sees is that. Right? So let's look at like what the meanings is. Okay? So there's load fast. Load fast is because it's loading a local argument, right? Because as you might remember from your Python training class, all arguments to functions are local variables. Right? Local variables are fast to load because you know in advance which arguments you have, so you don't have to load them by string or to get a dict. You know exactly which offset to take. So load fast the first local argument, right, which happens to be A. Load fast the second one, so that happens to be B. Then binary add. As you can see, this is smart enough that if the opcode doesn't need an argument, it will just not print the argument, even though the argument is physically there. So binary add, and then return value. So when you think of the eval loop that I will kind of show you in bits and pieces, remember that this is what it sees, right? At this point, it sees an opcode and an argument. Cool. But you saw that it needs an opcode and an argument, but the arguments were kind of implicit, right? It says 0 and 1. But if you actually call lambda a colon b, a plus b, we say the arguments 5 and 6, right? It will return 11, which means the 5 has to live somewhere, the 6 has to live somewhere, and those somewheres have to correspond to where the opcode say they were, right? The first place and the second place, respectively. So a frame is where these things happen, right? A frame has the code and the context, right? So the context is like what variables I'm having. When I return the value, whom do I return it to? So luckily, much like the code objects, the frame object is inspectable from Python, which means I can show you honest Python code and they don't have to lie. So let's have like a very, very simple calling structure. I have a function called foo. All that function does is call bar. Bar does something kind of a bit weird, right? So it defines a global variable called frm, and then it calls sys.getFrame. As you can see from the underscore, this is not a function you should ever use in production code, right? But that's okay, because this is not production code. This is slides, right? So I'm good. But it is very useful in like non-production code. If you ever want to kind of write an ad hoc debugger, you can literally put sys.getFrame in your code and like run it, and you have an ad hoc debugger. Ideally, don't release that to production, but you can figure out what's going on, right? Or you use a real debugger. And if you ever use a real debugger in Python, the way it works is, a big thing around sys.getFrame. So bar basically puts the current frame at the point where it exists in a global variable. The reason this is useful is because then I can call foo. I didn't show here that I called foo, but I did call foo before I did that. And I have a global variable called frm. Okay, so now frm is a frame object, and it is a frame object at the point when bar was being called. So it has a code object, right? Because remember, a frame is code plus context, right? So it has a code object, and I didn't want to show you the bytecode. The bytecode would not be interesting, but you can see that the code name is bar, right? So the code object has a name. The name, if you name the function, it will be named the same as the code object. So it's actually really nice to see. So when you call the frame, it's the frame that we're evaluating. It's evaluating code, and that code object happens to be called bar after the function bar. That makes sense because bar is where we recorded the frame, right? Now, the frame, unlike the code object, also has some context. One of the contexts is, what is my back frame, right? So this is dynamic calling, right? I could have another function called foo2, also called bar. And if I called foo2, now the back would be different, right? Now back would be foo2. So I did frm.fback fcode, and then I checked the code name again, because I could do the bytecode, but that would be kind of hard to understand. And that says foo, right? So, and then if you go one step back, right, you always go into the main context, which is called in Python the module context. It's kind of weird, but every evaluation in Python actually happens in the scope of a module. Your main just happens to be a really, really weird module as far as Python is concerned. Okay? So not only do you have access to frames, the frames are like handled in this like stack, right? You have the back, and you have the back, and you can kind of drill back all the way up to the top. Okay, so now we have the frame. The frame has the code and the context. That's great. So now we know what we need to evaluate. You take a frame, and you need to return a result. So how do you evaluate? So the Python evaluation model is what they call a stack machine. There's a few, in general, models when you implement some sort of like virtual machine. But definitely at the time that Python was written, and still a lot to today, even though there are like some dissenting opinions, one of the most popular ways is a stack machine. A stack machine has a very, very simple model. You have a stack, right? The stack supports two operations, push and pop. Right? It might support like other kind of like more exotic operations, and we might deal with them. But basically, so this will be what all the opcodes are working on. The opcodes operate on the stack. They do stuff to the stack. Right? So remember the load fast opcode we saw? That's pushing something into the stack. And because it was kind of easier to make these macros, Python defines these macros because they're going to be used a lot in the C-eval interpreter, basic push, basic pop. So this is not an abstract stack, but something actually used in practice. Python defines a lot. This is like a small sample of like other more exotic operations you can do on a stack. Again, mostly in the interest of performance. Theoretically, you could do every operation in stack in terms of push and pops, but it would be very slow to do that. So you can look at the top of the stack, or you can even look at the middle of the stack without changing the stack, which is sometimes useful. You can even change the top of the stack. Sometimes it's more efficient for unary operation to just set that instead of doing a pop and a push. All kinds of like, different variants on like stack operations, again, to keep your code running fast. Basically, remember that the stack, every operation has to do something to the stack. An operator that doesn't do anything to the stack just doesn't do anything. Okay, so now we know how things are going to work. They're going to like push and pop from the stack and maybe do some more exotic stuff to the stack. And we know what we need to evaluate, right? So this is how it looks from the inside C, right? This PyFrame object corresponds exactly to the frame object we saw from Python, right? So these are literally just different ways of looking at the same thing, right? You can look at it from Python, in which case it's called class frame, or you can look at it from C, where it's PyFrame object, right? But this is literally the same thing. And the throw flag, which is not interesting for our current discussion. And remember what I promised you in the beginning? Every single slide that has C on it is a lie. This slide is a lie. But it is kind of a good approximation to the truth and should help you understand what is going on. So first of all, we check what is the last instruction. This is important because frames can get suspended. If you ever use yield or wait, those are things that suspend a frame, which means that the frame needs to remember where it was last. That last I is basically the pointer to the next instruction. So we start with the beginning of the code, and we check with the offset. That's where we begin. Now we have a for loop, right? Because this is a bytecode loop, right? And it gets the opcode and it gets the oparg. Again, this is not the actual code in use because the actual code has all kinds of optimizations. And then it switches to the next instruction, right? And then it does a big switch on the opcode. In fact, the kind of nickname for that area in the code is the big switch. The reason it's called the big switch because it's very, very big, right? Python, I'm serious, right? If you think of it, Python is, a pretty mature language. It's been around for a while, and we keep adding operators to that, right? We added the walrus operator, right, most recently. That had to have an opcode here. I'm not going to talk about the walrus operator, right? I'm going to talk about things that have literally been there since ancient times, the 20th century, right? But I am going to give two different examples, right? So there's load fast, and this is a very common operator because you have a lot of local variables in a typical function, right? You're going to do that a lot. And you want to do it fast, right? And specifically, one thing you do is you don't go to the beginning of the loop, right? So if you remember, there's a thing here called fast next opcode, right? That's called a label in C. And fast operators immediately go to the fast opcode, which means they skip the beginning of the loop. This is important because other operators, for example, unary negative, which what happens if you do minus A, will not go to the beginning of the loop. That will not bypass the beginning of the loop. So then the loop will continue, right? And those are two kinds of bytecodes, sometimes known as fast bytecode or fast dispatch bytecode and slow dispatch bytecodes. So you might be wondering what's happening in the beginning of the loop that is A, so important that we need to do it a lot, but B, so slow that we don't want to do it too much. And the answer is it's the eval breaker, right? And there's all kinds of reasons to break the eval and do something else. The most popular thing that like every Python programmer has heard, sometimes in anger, is a global interpreter lock, right? Like we need to have a global interpreter lock. We need to figure out if we want to release it, we want to take it. It's a whole thing. Other slightly more exotic things is signal handling. You might have calls you need to do. And there's also async exceptions, which you probably have not used, but it's kind of a cool feature in Python that I do not have time to talk about. So basically, what happens is we check the eval breaker here, right? So if the signal's pending, we handle signals. If there's pending calls to do, we make them. If we are asked to drop the GIL, right, the global interpreter lock, we drop it and immediately acquire it, right? But that's okay, because when we drop it, some other thread will probably acquire it. And then we'll be stuck in trying to acquire it for a while that thread kind of does its own thing, evaluates bytecodes. And eventually it will drop the GIL because we tell it, hey, I want the GIL back, and it will give us back the GIL, which is exactly how the global interpreter lock works, right? It moves between the threads that are trying to execute bytecodes. And like I said, there's async exception, which is kind of an exotic but cool feature. So when Python actually gets a signal, it tries to do the minimal amount of work because that work literally happens in a place that Python can control. It does not happen in where it plans to handle signals. So all it does is just say, hey, remember, trip the eval breaker. So when we go to the loop, and not if we do load fast, right, but only if we go to the top of the loop, then we will try to trip the eval breaker. So what is the global interpreter lock protecting? It's protecting just Python bytecode evaluation, right? If you go into C code, that C code can release the GIL. I'm not going to go into the API for that. That's not really interesting. But let's look at how acquisition of the GIL looks like, right? So it's basically trying to acquire it. It's using a primitive that on Unix-based operating system translates to pthread cont timed wait, which is wrapped by a macro so that it can be portable to other operating systems. It's waiting on a signal. It's trying to acquire the mutex. It's trying to acquire the GIL. So this is, and it sets the GIL to lock. So this is how we get the lock. Releasing the lock is much easier, right? We just have to unlock, right? So if you're trying to acquire it, some other thread might be trying to acquire it. So you have to kind of make sure that you're not you're correctly coordinating with the other thread. Releasing it is easy. If you have it, you're the only one who has the GIL. So you can always release it, right? So this is how you unlock, and you send the signal. I've unlocked the GIL so that the other thread that is trying to acquire it will get the signal and try to actually get the GIL. So it's kind of like a complicated game, but this is what happens when you do drop GIL, take GIL, right? Like you first do the drop, and then you try to do the take. As you can see, the take is a loop. this can literally take an unbounded amount of time. It usually won't, because smart people who write C code will release the GIL around long-running operations. But if you use, say, some random C module, it can take a long time. It will not release the GIL, so it is an unbounded amount of time. That's basically all that happened in the loop, right? You do the kind of maintenance in the beginning, sometimes. You don't have to do the maintenance, because sometimes there's fast operations that will kind of skip that. And then you do you check what's the next instruction. You have a big switch. And then you do stack operations, right? So you do load fast, that's just pushing the value from the variable into the stack. You do binary add, that's pop the top two, add them, push the result. Return value, pop the value, and return it to the frame, right? That will end the frame. If you do a yield, which I didn't cover because that would be even more complicated, that is one of the ways to pause the frame, right? So you remember that the frame is not ready to garbage collect, and you put the last I and all these things. But it's not magic, right? This is all really straightforward code, except it isn't, right? Because remember that every single slide you saw was a bold-faced lie, right? Python is very sophisticated technology that is really, really hard to distinguish from magic. And if you actually read the CVal, right, and if you don't expect that, you will be shocked. You will see that it's magic. And remember, this is not magic. This is just the basic ideas are here, and then 20 or maybe 30 years of micro-optimizing every single line, because every single bit of time you saves all of you, and me, I guess too, a lot of time when we're running the Python code. And I think this is it. So thank you all very much, and I hope you enjoyed learning a little bit about the CPython eval loop.
We've got a break here. We will return at 12:10 with Emily's Line. Next up, we've got Emily Spahn, who's going to talk to us about the ethics of aesthetics. Take it away.
Hi, everyone. Thank you so much for being here. My name is Emily. I am a civil and environmental engineer turned data scientist and software developer, and I'm going to talk about a personal project that I have been working on. Hello. Next slide. Hello. There we go. Okay. All right. So I want to know if in the last 24 hours, please, by applause, by noise, please let me know if in the last 24 hours you have used... Hello. Okay. This is not happening here. Ah, okay. Sorry, thank you. All right, so in the last 24 hours, please clap or make some noise if you have applied makeup. So that would be, all right. Yeah, so any sort of color on your face. Now, I want to know if you've used any lotion, including lip balm, like maybe you have really dry hands. Okay, yeah. I would also be clapping. Now, deodorant. Excellent, this is great to hear, thank you. Deodorant, that's very important. And finally, I hope that you all should clap for soap. Because hygiene is very important. So the thing that all these products have in common are that they're personal care products. They are cosmetics. And they're all regulated in the US by the FDA. Now I want to know if, in the last 24 hours or so, have you looked at the ingredients labels of any of these products? Oh, very nice. So, I've been vegan for over half my life, and it's very natural for me to pick up a thing, and if it has an ingredients label, my eye just goes right there. And so when you start looking at some of these products, and you start looking at the ingredients labels, you have no idea what some of these are. They're these very scientific names, and who knows. So let's use a little Python and set up a system to evaluate personal care products and have a little fun. So I'm going to give you a bit of inspiration here. So I'm interested in combining safety data with ingredient sourcing data. So first, why safety? I just told you that the FDA regulates cosmetics and personal care products. Well, the FDA has a very light regulatory touch. Since the early 20th century, when these substances started getting regulated, since that time there have been a total of 11 banned substances. Things like formaldehyde and toluene, stuff that you do not want to be putting on your skin day in and day out. Now, if you can go and look at the European Union's cosmetics ingredient database and take a look at all the list of banned substances there. That list has over 1,600 entries. So that's a huge difference, 1,600. It's not an apples-to-apples comparison, because where the FDA says things like, okay, formaldehyde is bad, don't use it, the EU will say things like, okay, there's this class called formaldehydes. Now, formaldehydes in combination with this substance at a concentration of X% is going to be not allowed. And so they have a whole bunch of entries for each of these 11 substances, but they also do go a bit more, which is why there are third-party databases like the Environmental Working Group Skin Deep database, which characterizes safety for people who are interested. Now the flip side is ingredient data, ingredient sourcing. So for me, I mentioned I'm vegan. I'm interested in vegan and cruelty-free cosmetics. So I go to a resource like Logical Harmony that goes and does all of the hard work of contacting brands and figuring out which products meet those requirements. But I kind of want to go a little deeper than that. I don't want to just know if it's vegan. I want to know what it is. Additionally, I know that there's people who prefer to avoid certain types of products, like petroleum products. So I kind of want to just figure out what the original sourcing is. So and unfortunately, there are these specialty lists, but there's no list that I could find of easily determining the source of an ingredient. And I decided, okay, what are some of these like broad classes? I'll do plants and animals and minerals and petroleum. Additionally, these databases often go product by product, brand by brand. And I wanted to get away from product by product, brand by brand, and look at ingredients lists. So what are the data sources I'm using? Primarily, it was the Environmental Working Group data for safety and sourcing. And I used Wikipedia for its data, also for sourcing. There were several other references that I found. There are extensive industry references. I did stay away from those for various reasons, as well as some consultants. There's other, the Campaign for Safe Cosmetics. There's a bunch of different groups interested. So what's this project going to look like? So I want to go from a picture of ingredients label, and this came off of a tube of moisturizer that I had at home. So I want to go from that to this combined safety rating to mush together all the ingredients and give me back some sort of safety rating, and then give me some ingredients breakdown. Like maybe is most of it from plants and there's some salt in there, something to that effect. So now I'll show you what the actual output looks like. It's not nearly as fancy. At the bottom, I do have estimated composition and estimated safety score that sums everything up. But I also decided, at least while I'm testing and figuring this out, I want to have information on all of these ingredients that I detected. So let's step through how we can go from that picture to the final product. So the first part of the pipeline is optical character recognition. So we need to go from the photo to a text. I was pleasantly surprised at how simple PyTesseract was. And so we're going to take a look at some results. So this is the original image I had. It's maybe not the best. It's pretty fuzzy towards the edges, but you can still make out the text pretty well. And when I ran this through PyTesseract, the results looked pretty good. I don't know what's going on at the very end there, the 7ASA, no idea where that came from. But, you know, we're capturing these character returns. That's looking pretty good. So I decided to up the difficulty factor, and I did some sparkly packaging. I said, okay, this is going to be pretty hard. This is sparkly. It's flexible. Do we have any thoughts? Like, just think like thumbs up, thumbs down. So this essentially captured things from the middle and to the right. But it also did some weird things. So it kind of just ignored all the stuff on the left hand of the image. But you see there's like weird pipes, vitamin C at the very end. The C didn't get interpreted as an actual C. We have stars getting interpreted as quotation marks. Oh, okay, well maybe it's not that simple. So I figured that was a pretty unique case. So let me try a more reasonable image. So I grabbed this from a Dr. Bronner's bottle, the soap bottle, and I said, okay, this is text on a curved surface. There's some text cut off the edge. Let's see what happens. So what do you think? Thumbs down, thumbs down. Oh, I'm seeing a few thumbs up. Okay. What? What? I saw this the first time and I said, what are you talking about? There is no NBA. Like, where does that, what? Okay, so I said, all right, obviously I'm asking way too much of this service. And so I did some image correction. I used GIMP, the new image manipulation program, and did some, like, a 5-minute Photoshop job where I tried to crop it a little better and I tried to straighten out the text. So now, we do a lot better. Still some weird funkiness. We have stars for organic indicator being interpreted as quotation marks and question marks. I don't know why there's that equal sign at the very beginning of ingredients. Presumably the wrapping edges are problematic. So, Yeah. Next logical step is to play around with OpenCV and improve the text detection. But I decided I'm going to proceed with the rest of the pipeline because I wanted to. I can come back to this. I think this is a solved problem, and there's probably a lot of tools to do this. So next, we need a database. So we need information to look up. And so that meant web scraping. So I used Selenium and some pandas to do some of the number crunching there. And I did put a note, follow the robots.txt. In this case, there was I think it was like a 10-second wait time between requests. So I said, okay, well, I'll take a few days and just parse the whole thing. So the main source that I used was the Environmental Working Group's Skin Deep database. This is an extensive resource. They do products, brands, and ingredients. It's not affiliated with industry, which is great. It has simple safety scores, which is even better. It's easy to digest and understand. But of course, we do have to recognize they can be a little overly alarmist, especially given that this is something that they do make money on. And I shouldn't say make money, but they do, they fundraise on. But the nice thing there is that if you search a star, you can get a list of all of the 9,000 ingredients. So I went through and I scraped all of them. And I didn't scrape the entire page. I was most interested in this top section I'm showing you here. So we get the name, we grab the score. Interestingly, the score is stored not as a number value, but as a URL. So you have to parse the URL to get these values. If in some cases there are these ranges of scores, depending on usage, in those cases I just took the average to come up with a single unified score. I also grabbed on the bottom the other concerns functions, and most importantly, these about the chemical. Sometimes that contains sourcing, and then synonyms. And so the synonyms are actually quite important, and it's important in the way that we think about storing these ingredients. This is actually quite a bit harder than I expected. There are a whole lot of different names for the same ingredient. There are actually conflicting regulations. So sometimes the guidance says, oh, put the scientific name first, then in parentheses, put the common name. Sometimes it's vice versa. Sometimes there's no parentheses. Additionally, you might have artifacts from the image to text issue to deal with. So to give you an example of what I'm talking about, these are all the ingredient names that I scraped, including the synonyms, that include aloe. So there's like 80-ish there. And one of the things that I noticed was the second ingredient, I mean, if you don't want to count water, the first ingredient, in my lotion was aloe vera juice. And I'm thinking, okay, great, there's like 80 kinds of aloe vera in my database, so surely it's got to be in there. Jerks. So I looked up similar names, and man, we're so close. It's just, we just don't have that right combination of words in exactly that right order. So there's a large variability in these names, so how do you deal with it? And then at this point I realized, oh, this is why Environmental Working Group probably has humans and volunteers looking through, because there is so much variability in these data. And I still haven't figured out the best way to, how do you parse these ingredients and look them up so that you're not capturing the wrong ingredient. So let's move on to the sourcing portion of it. This was pretty challenging. And I decided to use a natural language processing approach. So the whole point here is to try and figure out if the ingredient is derived from an animal, a mineral, petroleum, or a plant. So I opted to use Flare NLP for this. It was the first time I had used that particular package. It seemed to have a whole lot of state-of-the-art NLP tools in it. So I said, hey, I'm doing this to learn. I might as well learn this. Other packages I've used in the past, NLTK, Jensen, Spacey. There's some really great stuff coming out of Allen NLP that I haven't dug into yet that I'm looking forward to playing around with. There's a lot out there. It's a very active field, and I only barely touch on it. So one thing that's interesting to think about is that the same ingredient can come from multiple sources. So how do we deal with this? In the example I have here, we have glycerin. And most glycerin is from plants, but it can also be derived from animals and from oil. So how do we want to account for the sourcing of glycerin? To make things easy, I said, okay, let's just aim for choosing one source, with the thought that, okay, most ingredients are only going to have one source. But of course, that's not as simple as that. There are some substances like silicone, which is a combination of a mineral and oil. So what do you do with that? Additionally, there are substances whose sourcing has changed over the years. So squalane, it's often used in cosmetics. It doesn't clog your pores, which is really nice. It used to be derived from shark liver oil, and actually still is often. But now it's often also made from plants, from olive oil. So how do you classify that? Can we call that plant, or do we call that vegetable, or animal? So some things to think about there. So I need to touch on word vectors to get into the method that I'm using to get at these sourcing. So the notion with word vectors is that words can be represented as vectors. So it's this notion where each entry in a vector is representative of some concept. So in this example here, this is kind of the canonical example for word embeddings. We have the vector between king and queen being parallel to the vector between man and woman. And that's because the gender is encoded in that direction in that vector space. I'm not going to talk about it anymore, apart from mentioning that they exist. So for a given ingredient, we're going to come up with document vectors. So I have two separate sources. I treat them separately, and then I combine them at the end. First is the environmental working groups about the chemical text, because as I mentioned, sometimes that contains sourcing information. I feed that through a word embedding model. That's one of these state-of-the-art models that's come out in the last 2 or 3 years to get a document vector. Do the same thing for the Wikipedia entry for that substance, for using both the summary and production. So combine them, you get a document vector. Great, now what do we do with it? We need to have something to compare against. So we come up with reference vectors. We have plants, oil, mineral, and animal separately. I take the Wikipedia text, feed them through this BERT word embedding model, and come up with reference vectors. And finally, we can use cosine similarity and figure out what the best match is. So we essentially pick the vector that's closest to the ingredient vector. And that's why part of the reason I said, oh, let's just pick one source, just because this makes it easier. So how well did this work? Yeah, so remember my example with the sourcing, and I have the detected ingredients there. Pretty much all of them are wrong. Whoops. And so this approach needs a lot of work. I do actually think the general approach will work, but probably some new source data is going to be needed. So in the process, I'm like, okay, I should create some training data. So I started picking out random ingredients and started Googling or Wikipediaing. And some of these entries in Wikipedia, you really do need a chemistry degree to parse. And I am not at all a chemist. So I think that would, having some sort of new source data, I don't know what that would be, as well as actually doing some tuning, actually adjusting settings. I said, oh, let's just take it out of the box. Let's use these default settings, see how good it does. Which is fine for a personal project, right? And so once we do come up with these, I did want to think about, touch on a little bit how we can store them. So we can use a graph database. I think that would be suit fantastically. We can include single or multiple links between ingredient sources and ingredients. We can store alternate names and safety data as node attributes. So finally, we need to put these separate ingredients together. And there's a big assumption here, and which is I'm ignoring the safety impact of combining any two ingredients. So the general example here is, when you're cleaning, you're not supposed to use bleach and ammonia at the same time because you could accidentally create chlorine gas and gas your insides. That's not good. Far less likely to happen when you're combining like oils and seeds and such to make lotions, but that is still something. So what do the regulations say about ingredient order? So this is directly from the U.S. Code of Federal Regulations, and it just says ingredients should be listed in descending order of predominance. And then once you get to 1%, it can be in any order. Oh yeah, and by the way, if you have any color additives, feel free to just tack them on at the end. So it's not really a whole lot to work with. So I said, okay, we're going to do the simplest thing, which is taking a linearly decreasing proportion. So let's just assign that. We'll do a weighted average based on those proportions to get a total safety rating and category estimates for the product. And that way, we put it all together, and we can come out with an estimated composition and an estimated safety score. Of course, there's plenty of ways to improve. Image correction for the text, improving the sourcing. I did not realize how difficult that part of it would be. Thinking about having a better ingredient name lookup. Do we want to try thinking about standardizing names? Of course, also I didn't do any sort of front end or interaction like website or Twitter bot or something. So let me end on with a few notes. This is not the bestest, most well-organized code, but it is all there for you to browse if you'd like. I want to thank my employer, Drone Seed. We use heavy lift drone swarms to reforest vegetation, particularly after wildfires. It's awesome. We are unfortunately not hiring engineers right now, but if you are a production or a logistics person, or if you are a researcher in seeds and biology and forestry, take a look at our website. And also, if anyone has like hundreds of acres of land that you want reforested, let me know. And then finally, I just want to add to the land acknowledgement and ask that you look into efforts like Real Rent Duwamish to support the tribes on whose land we all live. Thank you very much.
Hi, sorry about that. I have an announcement to make. This is just regarding the lightning talks. We have our lightning talk speakers. So Thursday Bram, Luke Lee, Connie Rodriguez, Synix, Yessi Garcia, and Athens Spathas. Check the lightning talk channel, and if you could, please have your lightning talks in PDF form sent to Katie by 1:30. So yeah, enjoy lunch. We'll be back here at 1:50. So.
Times like these are here to show. You can do things for me and more. I got your back, just take things slow. Wanna take mine and get close. Understand, I know how things flow. Please just say my word and think you know. We say I'm all I pray, you know. let me see. I'm blinded by your love. You follow me, but I don't know where to go. I see my feelings so true, but am I blinded by you? By you. Made it all the way through, but am I blinded by you? By you. See through me, I don't mind it at all. Make me believe that you're all that I know. I see my feelings so true, but am I blinded by you? By you. Made it all the way through, but am I blinded by you? By you.
afternoon. Good afternoon. There we go. We have some more lightning talks for y'all. We have 6 wonderful speakers. Each of them get 5 minutes. I have a phone in which I will be timing them. Ooh.
About politics. Maybe too much, maybe not. It's hard to tell. I work with a couple of different campaigns, and there are some technical skills every campaign needs, and one of them is Google, which sounds really basic, but I'm not talking about just putting a bunch of keywords in and hoping really hard that you find something. I'm talking about like the type of Google where you have a partial error message and you have to go spelunking into Stack Overflow and hope that you find something. That skill is surprisingly valuable on a political campaign, especially for local politics where you are trying to find whatever form that you have to have filled out to be a candidate, which is buried somewhere in the state website in a PDF that is unsearchable. So Google is a really valuable skill there. Next, integrations and API plumbing is basically what I call like taking a bunch of tools and squishing them together. A lot of campaigns wind up using a large variety of tools and then have to move data between one or the other. I have seen an entire room of volunteers cutting and pasting between tools, and it's terrible, especially when in some cases it can be as simple as downloading a CSV and then re-uploading it somewhere else. So being able to understand integrations, APIs, all of that sort of stuff is really valuable in politics, no matter what kind of campaign you're working on. Data wrangling is also super helpful, and when I say data wrangling, it can be some bare bones stuff, just finding random spreadsheets and doing all sorts of things with them. Most recently, I managed to get the full list of unreinforced masonry buildings in Portland, which is a big deal if you care about seismic activity. But it's just the messiest spreadsheet you've ever seen. I have seen like church social spreadsheets that were cleaner than this. So just being able to, you know, look at a spreadsheet and not cry is a great first step. Being able to actually then do something with that data, whether it's moving it into a particular tool or cleaning it up or generating reports or visualizing it, all of those things are very important and a skill set that especially small campaigns rarely have. I know this one is the one that everybody hates, but websites really matter in politics, and especially if you look at like the school board races or things on that level, if people have a Facebook page, they're doing real good. So when I say website management, I'm not talking about like building the perfect website from scratch. I'm talking about setting up a WordPress install, sending around the tutorials to everybody, and then just making sure that it doesn't fall apart. It's pretty basic, but very important. And this is the one that I think we all actually want to be doing. It's not the biggest part of supporting any political campaign, but there's lots of cool new stuff that you can build depending on what the campaign's constraints are. So for instance, with local campaigns, there's some tools that are already available for doing mapping and looking at canvassing using local maps. But most of them are very localized to a specific place or a specific campaign. So building similar tools can be really useful. For example, there's an app called 5 Calls, which basically you open up the app, it gives you a script and a phone number for one of your federal representatives. You hit the button, you call in, you read the script to the staffer, and you have participated in the political process on a fairly easy way. That sort of thing doesn't exist at the local level, but it can be as simple as like putting together a list of contact information and then going over to the Twilio booth and saying, hey, help me out with this. And then also very important in this room, if you have one of those sexy tech salaries, consider helping out the local campaigns. So it's not even necessarily a large amount that a lot of campaigns are looking for. Here in Portland, we're doing our first year with, let's see, free and fair elections. So $250 makes a huge difference. And also accounting and mapping and GIS is important. Bye.
Thank you, Thursday. That is what 5 minutes looks like. If you see me sneaking up to stage, that means that there is 5, 4, 3, 2, clap, 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 clap. Connie. This talk has an amazing title. Connie is going to be speaking about Once Upon a Talk, Optimizing a Data-Driven Princess Dating Algorithm. Connie, where'd you go? Come on. Yay.
Hello, guys. Are you guys having fun yet? Yeah? Great. All right. So for my talk, I would like you guys to imagine that we live in this storytell kingdom and that our job is to help this princess optimize her dating algorithm. And this starts one day when the princess decides to announce to the world that she's ready to find love. We close our eyes, we open our eyes, and there are 100 people waiting outside the castle, waiting for a chance to meet the princess. Now, the princess is a very busy person. Let me see. She doesn't have the time to date everybody, so that's where we come in. So let's say that these frogs here looks a little bit different. Okay, whatever. So these frogs here represent the 100 candidates, and the numbers that are pretty hard to see represent the quality of that candidate. So this is going to be a ranking system. So what that means that if we have 100 candidates, our objective will be to find Prince Charming, who has a quality of 100. So because this is we are comparing candidates, the princess will need to go on some dates, some practice dates. We're going to call that the test group. And then the rest is going to be the select group. The test group are going to be the practice dates, and then the select group will be the group from which the princess will actually make a selection. So here's my code. I don't know if you guys can see that, but I just want you to see what the parameters of my function I are. Size of applicant, size of test group, simulations, the seed random number, and then the metrics. I want to talk a little bit more about this middle part. This is what's happening with every simulation. So with every simulation, we are assigning the test group and the select group. We're also saving the best candidate from the test group as the test group best. And then the princess will start dating people from the select group. Hopefully, she will find someone that is better than the test group best. If that is the case, she will make her selection and she will stop dating. If that's not the case, she'll be like, no, thank you, you're not really what I'm looking for. And then she will continue dating until the first condition is true or she runs out of applicants. So here we have a histogram. This is for 1,000 simulations and a test group of 50, so half the candidates. And we can see that for a little bit less than half the time, the princess decided that she'd rather be alone than date someone. So the princess takes a look at this, and she's not happy with it. But that's okay. We're going to improve it. So we start looking at the probability of selecting Prince Charming against the size of the test group. Let's do this for 10,000 simulations since we can. This allows us to see a more clear behavior, and we can see that the test group should be 38 according to this. We can do something similar for the average quality. According to this, would be a size of 5. So here we have a histogram with a test group of 5, and it is starting to look a lot better. We have a lot more selections on the right side. Okay, and the princess feels a little bit more hopeful, and so do we. But I think we can do a little bit better. So let's change our strategy a little bit. Maybe instead of looking for Prince Charming, let's change our strategy and maybe try to select the top 2, top 3, top 4. What this shows us here, so the lighter the color, the better the average quality. So we want to be on the top 4 best and a size of 35. Let's put that on a histogram and let's see what that looks like. All right, it looks a lot better. Almost everything is on the right side. The princess takes a look at this and she's happy. So this is what we're going to go with. So we have effectively created a model, a dating algorithm that results in a 95 out of 100 average quality. And the cool thing about all of this is that we didn't need thousands of princesses kissing frogs in order to figure this out. If you would like to learn more about this specific problem, you can go to the GitHub page. This problem is called the secretary problem. You can go to my GitHub. I also have a NumPy version for running 100,000 simulations. And I'm looking for a job. Have you guys noticed that? Yeah. All right, well, that's all I have for you guys. Thank you very much.
Thank you so much. The glitch animations come for free. Next up, we have Yezi with Work in Progress, Data Dictionary. Make Yezi feel welcome.
Thank you. Hi, everyone. I'm Yesi. And I'm going to talk to you about a work in progress project that I've been working on, and it's a data dictionary. We all know that developing documentation is tough and maintaining is even tougher. And building a data dictionary or catalog is no exception. So I've helped support a code base of a lot of files, over 100 files, all complete with table definitions. This is primarily in SQL. Each file is average about 800 lines of code. That's a lot. We process over 90,000 lines of code daily, creating over 120 production tables in our production schema ready for analysis. The problem is that our analysts have a heck of a time with data discovery, trying to understand what is available in our production schema over time. This changes. We get new inputs. The production tables themselves that have existed for a while change. So we need a data dictionary. So I have an idea. Since we have all of these files ready and available with table definitions at the top per our requirement for code review, we can actually extract that data from the files themselves. As you can see, that's a lot of lines of code, but we only really need a specific portion of that file. So the first thing that I've done is take a function that I found on Stack Overflow, which returns the text between two substrings. So in this case, I'm very familiar with the pattern of our files. And so in here, I look for table name, which is a variable that we provide, and grant, which grants access to the tables themselves, to return the DDL, the table definitions. So this isn't quite enough. We actually want to be able to present this to our analysts, to our end users in a consumable way. And the second part of my idea, which is very much a work in progress, is to actually create a dashboard for a data dictionary. And this is a screenshot from Traverse Media YouTube with their Flask from Scratch tutorial, where he creates a dashboard, a table based on a database that he created using the outputs. And I would like to do this for the previous slide, for that DDL there. Actually create a dictionary from a dictionary. So I would love to hear your ideas. What am I missing? Are there other solutions? Has anyone here tried to develop their own catalog? And if you do have ideas, I have an open space at 2:35. I would love to hear from you. Thank you.
Thank you so much. Now we have Luke. Just a moment. Now we have Luke with Shipping Simple Python Desktop Apps.
Thanks, everybody. So there's two main points of this talk. Hopefully I'll introduce you to something you haven't seen before, and then I'm also going to beg you to help me keep it alive. So my name is Luke. I couldn't come to Portland. My favorite book is Fight Club. I couldn't make a slide without putting Fight Club on it because the author is from Portland. So if you want to contact me, this is the way to do that afterwards. So what I tend to do is develop Python applications and ship them to users that aren't actually Python developers. So if I were going to tell my users, oh, go and install Anaconda, pip install this, all of us in this room, I can give you a requirements file and a wheel, and everybody is okay with that. It turns out that we're a pretty rare group. Not many regular users are going to be able to do that. So what's missing? Well, like I said, I can't go and tell my users to install Python, because then I'm going to get a bunch of really weird looks, and people are going to ask me why I want to put a snake in their machine. So how do I do that? And there's a couple of good ways to do it, but one thing that I want to introduce is a thing called PyInstaller. So PyInstaller has been around for a long time, and what I like to call it is double-click magic. So what you do is you give PyInstaller your entry point or your main script, and it will bundle up everything together and then put the Python interpreter, all of your dependencies and stuff together. And then you can ship that to a user, and they have no idea that you're using Python at all. So that's what's really great about it, is you can do a bunch of Python development and then give someone a machine or an executable, and they have no idea what it was written in, because end users don't care. We're all at a Python conference because we love Python, but most users just want their app to work. So the way PyInstaller does this is way too complicated to go over in 5 minutes, but essentially you pip install PyInstaller, you get another executable on your path, and then you point it at your main script, and it does all this magic. And then you can distribute either a folder with all the DLLs and shared objects and stuff to your users, or you can distribute just one executable. So what does this actually do for you? It gives you a bunch of freedom, because now you can change from Python 2 to Python 3 across releases and no one cares. You can do a whole bunch of NumPy and SciPy and Matplotlib and all these really complicated dependencies, and no one has to know that all that stuff is happening behind the scenes. I've been doing Python for a long time, and it used to be that installing SciPy was not as easy as pip install SciPy. You had to have a Fortran compiler, a C++ compiler, and know how to use all those things in Windows. So I first want to thank all the people from Anaconda, the people that are working on the Windows Python installer, and people that make wheels, because all that stuff is really great. But my particular use case, I can't just pip install stuff because users won't know. So again, PyInstaller is going to give you a bunch of freedom. Also, PyInstaller is not new, it's just really good. There's a bunch of other things to do this sort of stuff, but my experience, PyInstaller has been the best. And I've been using it to successfully, covertly ship Python-developed applications to users for probably 7 or 8 years now. So PyInstaller is kind of like this car. Maybe it's not the newest car, but it just really works. So why am I up here talking to you about this? Well, one, I've contributed to PyInstaller, but I'm not the person that's running the project. You could call me just a PyInstaller fanboy. And I happen to have a microphone, so I want to convince you all that PyInstaller is really cool. But there's a big problem now, is PyInstaller needs your help. The lead developer has decided that he has been spending too much time on this, and he doesn't, he has kids and stuff, he has other stuff he has going on, and he can't do it without our help. So there's a PyInstaller issue on GitHub talking about different ways to get funding. So I think this is a really great resource in the Python community, and I don't want to see it disappear. So I'm ready to talk with anyone how we can help. There's TideLift, there's NumFocus, there's the PSF. Maybe users want to contribute money or time. I don't know the solution to this problem. This is a classic sustainability problem in open source that PyInstaller is hitting right now. So if anybody has any ideas on how to do that, or you have never seen PyInstaller and you want to see a demo of it, come up and talk to me. I'll show you how it works. And yeah, let's just not let this great resource go away. That's all I got. Thanks.
Thank you for that. We may just need a short moment to make sure that the slides are working again. Haha! Hey, it looks like it's staying still now. That's great. Next up, we have Synix with Python for non-developers.
Hi, everyone. This is my first conference ever for anything. And I just want to say that it has been the most amazing experience, and I'm going to go to all of them now. So this talk could have 3 different titles. The first would be Python for non-developers, superpower in everyday life. I'm sure that's very self-explanatory. The second could be from micromanage to micro workload. And the third could be how I got a promotion working 1 hour a day, which is very, very true. So basically, a bit of background. I got an opportunity to work for Microsoft under Microsoft Ads. And at the time, it seemed like a great opportunity. We were working with Nike, we were working with World Wildlife Fund, we were working with Blizzard Entertainment, all of these great places, but everything was being done in Excel. Everything. We did not have a client management system, so we had to work with over 50 clients a day and keep track of them in spreadsheets manually ourselves. And being someone that is very innovative by default, I just really wanted to make a difference. So I kept going to management, like, we should improve this, we should improve this. And every single time I did that, I got in trouble. I'm being serious. I got in trouble. They did not like me. They thought I was a thorn in their side. And then suddenly, after talking and talking and talking and talking and talking, I went silent. There's a subtle art of shutting up. And that is exactly what I did. I just stopped what I was doing, and I learned about the Pandas library, and I just determined, fine, I'm not going to innovate. I'm going to do exactly what you want. So I automated my entire job 3 months after learning Python. Which is really fun. If you think about that, the barrier to entry is not actually that high. There's a lot of great people that are contributing to great things. So I did that, and basically I just made it look like I was working really hard. I used to schedule messages to go out at like 4:15 in the morning and like 10:30 at night. I convinced my boss I was too busy with the workload because I was producing these great results, right, out of the blue. And I was too busy because people were asking me questions. And everyone was so satisfied that I got this promotion. And then I convinced them I was even busier. So I just sat in the lunch auditorium, and all my friends came and hung out with me. And I learned I learned Python like 7 hours a day. So that was my job. So I have a better job now, and I actually work for these people because I believe in them, and I am building Google Ads campaigns. So for all your non-developer friends, I just want to show how easy it is to build a Google Ads campaign in Pandas in like 2 minutes. So first, you create a keywords list. You create an append keyword list, a prepend keyword list, and then a type. So you would say, buy a house, buy a condo, buy a duplex. It's all the same thing. There's a lot of industries that are like this. And then there's things that are prepended, like buy a house near me, houses for sale. And then you take your keyword type, and then you smash them all together. This is very simple code. You just append or prepend them, and then you put them into one list. Then you go into Pandas, you create a simple data frame, you add in your keywords with the list, and that is it. You have created that. Ad groups are just right across the board. So for every keyword, you create one ad group, and then you create one campaign. That's how it's recognized within the system. So from this, you just have to create your keyword types. So you want exact match that says if somebody types in something exactly, it'll pop up your keyword. Then there's phrase match. So if someone says, buy a house, and then it says near me, then it's going to go through, okay, 15 seconds, go, 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 go. As soon as you do that, you upload the entire thing, and boom, the entire campaign is done, ready to launch. I took on an entire agency in 6 weeks, outperformed them, and that is the honest truth. Python rocks for everyone.
Thank you so much. Oh, that was the... Okay, cool. Okay. Our final speaker needs a little bit more setup time. There are flashy lights. It's kind of cool. Yeah. We have Ethan talking about Python is greater than or equal to superglue, the making of the glass beat station. Ooh. I will be kind, and I won't start the timer until he gets the microphone.
Can I test if there's audio coming?
can I make a perfect world? A place where you and I would work. You put me in a box of words. No longer feel like vibes of blur. You're wondering what's on my mind right now. It's how you sound. The first time we grow up is us.
lovely talks with me this afternoon. First up, we have Catherine, who will be talking about Pyambic pentameter. Let's make her feel welcome.
Great. Good afternoon, everyone. Welcome back. And as Katie said, I'm going to be talking today about Pyambic pentameter, or maybe Poetry 101, but for computers. So I promise we'll unpack the rest of that subtitle as we go along. But for starters, this is where we're going to start. So at this point, you might be asking, what kind of poem, or even what is a poem? Let's talk about that. So poetry is a really broad category. Like, there's a lot of things that can be counted as poetry. It's about capturing beauty and emotion with words. It's even about using the properties of the words themselves to add layers of meaning to your text. So what does human-written poetry look like? It might look like this. This is my first poem. Shout out to my parents for finding it. Shout out to my parents for keeping it. And it goes like this. There was a child, had a hood. He liked it so much, it was good. So we'll be looking at what makes this a poem. But let's check out a different example. Shout out to the Untitled Goose Game. We all love the goose in the game who's recently waddled to fame. A nihilist force, devoid of remorse, a bird without pity or shame. So this is a form of poetry that's commonly known as a limerick. It's got a few things that make it a limerick. It's got 5 lines. 3 of those are long and they rhyme with each other. 2 of those are short and they rhyme with each other. And it's got this rolling rhythm. We all love the goose in the game. And it's often humorous. One other kind of poetry. This is what you might think of, like when you think of a stereotypical poem. So this is one of Shakespeare's 154 sonnets. It's number 18. Shall I compare thee to a summer's day? Thou art more lovely and more temperate. Rough winds do shake the darling buds of May, and summer's lease hath all too short a date. So Shakespeare wrote 154 of these, and one of the reasons they're notable is because they all follow the exact same format. They're all 14 lines long. Every other line rhymes with each other, except for the last 2, which rhyme with them, like they rhyme with each other. And every single line has 10 syllables, and every line also follows the pattern of an unstressed syllable followed by a stressed syllable followed by unstressed. Shall I compare thee to a summer? It doesn't sound the same if you read it, shall I compare thee to? And that's meter in poetry. So what do all of these have in common? They all have rhyme. They have lines that end in the same sound. And they all have meter, which is what I was just talking about. It's the pattern of stressed and unstressed syllables and the number of syllables per line that make it sound beautiful. And this is awesome because that's a pattern, and computers are great at patterns. So we're going to start from scratch here. And eventually we're going to teach a computer to write a poem, but first we have to teach it just how to write. So there's a lot of ways you can teach a computer to generate random text. You can take a really simple strategy. You can take a dictionary full of English, perhaps, text, pull a bunch of words out of it, string them all together, and hey, you've just put a bunch of English words together. You know they're all in your language. Maybe it makes sense. Maybe it doesn't. You can do something really sophisticated. You can take a neural network. You can train it on thousands and thousands of pages of English text, and it can output things that look like that. But we're going to split the difference here. My favorite approach to generating random text is called Markov chain models. And they're great because they're easy to understand, they're easy to implement, but they also have some semi-coherent output. And that's probably fine for poetry. So the idea behind Markov chain generation is that English has a word order that matters. You can say, the cat sat on the wall. But if you say, the wall on cat sat the, that doesn't make any sense. You don't know who's doing the sitting. It's the placement of the word in the sentence is what gives it meaning. So Markov generation uses a source text to tell us what an appropriate word order is in order to inform our generation. So in honor of the walrus operator, newly minted in Python 3.8, I've, shout out, I've picked a source text that consists of the chorus of I am the walrus. I am the Eggman, they are the Eggmen, I am the walrus, goo 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 joob. Thank you, John Lennon. So the first step to generating text with Markov chains is to randomly pick your first word. And this can be any of the words in the text. I have randomly picked the word I. In order to pick your next word, you're going to look at where that appears in the source text. In this case, it appears twice. And both times it's followed by the word am. So when we pick our next word, we're going to choose from that selection. In this case, there's only one choice. We're going to pick the word am. And again, we're going to look at where am appears in the source text. Our only next choice is the. And here we have a branch. So when we look at the, it appears 3 times in our source text. Twice it's followed by the word egg, and once it's followed by the word walrus. So our next choice, our next word that we generate, we're going to pick egg 2 out of 3 times with a probability of 66.odd%, and walrus with a probability of 1 out of 3. Statistically, we're going to pick the word egg. And here, again, we have a choice. We can either pick the word man, 50%, or men, 50%. Perhaps we pick men. And now we've got a sentence that we just generated randomly out of this text. And it says, I am the Eggman. And one thing you might notice is that while every adjacent pair of words it appears in the source text somewhere, the entire sentence does not. We've made something new. So how do we do this in Python? We're going to start by building a model out of our source text. And if you're a beginner, don't worry that this model is such an abstract concept. All it means is that we're going to go through the text and organize the data that we need out of it in order to make our generation easier. So what we're going to do with our model, first we're going to take the source text, which is just a string, and we're going to split it by white space so that we have a list of words. We're going to initialize our model to an empty dictionary, and then for every word in our source text except for the last one, we're going to add it to the model, if it's not already there, as a key. And the value is going to be an empty array. We're going to look at the next word, and this is why we don't iterate through the last word, because this is going to give us an index error otherwise. We add that to the list of words in the model that's keyed by the word that comes before it. And then we bring it back. So what does this actually look like? If we build our model on the chorus of I am the walrus, it looks like this. Every word, every unique word that appears in our text is going to be a key in the dictionary. And the value of each of those is the set of words that follow it. So you'll see the first 3 entries in this dictionary were things that we used in our example. So how do we use this model to generate text? We're going to use the random module. And we're going to write a function that is Markov generation, given the source text and the number of words that we want to output. So our first step is to build this model. That's the one we just built. That's what it looks like. We're going to randomly choose one of the words in there to use as our seed word and initialize our output there. And then for the number of words we want to generate, we're going to look at the last word that we generated. This is why we seed it with a word. We're going to pick a next word randomly out of the choices available from our model and add that to the output. And if we've picked the last word, which may not be in our model, we're going to end early because we don't know what can possibly come next after that. We don't have an example. Return it as a string with spaces. So what does this look like when we run it on our example text? I am the Eggman, yes. Here's what we get. The Eggmen, I am the Eggman, they are the walrus, goo 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 joob. It should look pretty familiar. It's got the same general pattern as the source text. It does have some new features. They are the walrus. That doesn't appear in the original song. Something else you might get. Men, I am the walrus, goo goo joob. You'll see that because I tried to generate a large number of words, most of these end in the last word of the source text because we don't know where to go next. My personal favorite here is goo 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 joob. Okay, so this is awesome, right? Like, we've made entirely new text out of a source text. You can play with so many inputs here. You can put in the text of your favorite song or your favorite library documentation. If you put in the text of a book, you can get fan fiction out of this. Uh, if you use two different sources, then in the words they have in common, you can get some really fun joins. And I'd love to see what you come up with. But we're talking about poetry here, and for poetry, we need one more key. And so I turned to the Natural Language Toolkit, which is an industrial strength, like really, really powerful library for natural language processing tools. It can do sentiment analysis, and it can do sentence splitting. And what I am going to use out of it today is the Carnegie Mellon Pronouncing Dictionary, or the CMU Dict. So this is a giant dictionary, literally a dictionary in a couple of senses. One, in that it has almost all of the English words in there, and a bunch of words that are proper nouns or names, places, and what it looks like. It's also a dictionary in the Python sense. So when we use it, we're going to load this dictionary, load the dictionary from that dictionary, and then look up a word. And what it looks like when we look up Python in this dictionary, we get a list of lists, and the contents of that list, of the innermost list, is a standardized version of how to pronounce this word. It's broken down by sound. So we start with a p in Python, and then we go to I, th, ah, n. You'll notice that the vowels here have numbers next to them, and that's what indicates the syllable stress. So a 1 is a stressed syllable, Python. A 0 is an unstressed syllable, and this indicates that we say it Python and not Python. So the reason it's a list of lists is because if you look up a word that has multiple pronunciations, you're going to get all of them. So you might say this word different ways depending on if it's a noun or a verb or just who you are and what your accent is. So the pronunciations that we've got in the dictionary are separate, separate, and separate. You'll notice that one of these has a 2 next to it, and that indicates a secondarily stressed syllable. It means it's okay if you stress that syllable, and it's also okay if you don't. You can say separate, or you can say separate, and they both sound okay. So this is all the tools we need. We know how to write text, and we know how to pronounce it. So we're going to go back to our poetry. So the 2 features that we're looking for in a poem, number 1 was rhyme. And I'm not going to lie, the way I did this feels like a hack. It's like one of those horrible interview questions where you either see the answer right away or you spend 45 minutes doing something super complicated. So the idea behind a rhyme is that we want text to end in a sound and then another set of text that ends in a similar sound. And that's hard. If you want to trace a path through your source text with Markov, you don't really have any guarantee about where you're going to end up. But it's pretty easy to figure out where you start. So we're going to flip the text order, build our model backwards, and then use some criteria to pick our seed words so that they rhyme with each other, and we can get 2 randomly generated texts that will end in a similar sound. So what I did is I went through the source text of I Am the Walrus. I've expanded this to the full song. And I ran it through the pronunciation dictionary. I got the pronunciation for everything, and I cut it off at the last stressed syllable, and that indicates what sound this word is going to end with and what other words it will rhyme on. So this top row is the sound O, and it's emphasized, and it rhymes. The words that end with that are grow, row, po, and ho. At the last word, you can see why it matters that we've cut off at the last emphasized syllable, because city and pretty rhyme with each other, but something else that ends in, like just the word T, might not. So the way we're going to generate rhymes out of this, we're going to randomly pick one of the sounds. We're going to randomly pick, say, 2 of the words in there, and then Markov generate backwards so that we've got words that end in those sounds. Cornflake, waiting for the sky, and Eggman, you've been a sty, were my results. So this is great, but it's not poetry yet. Like these are the same number of words, but they're different numbers of syllables. And that's where we're going to talk about meter. So meter's a little harder than just rhyming because you need to evaluate the words as you go along. So we are going to, as we're picking words, we're going to compare them against a meter that we're looking for. So we're going to start with a meter that we want. And as we pick those words, we're going to compare them. If they fit the meter, we're going to keep them. If they don't, we're going to throw them out. If we find that we've backed ourselves into a corner, that we don't have a path forward that has the right meter, then we're going to backtrack. We're going to erase words until we do have a path forward. This is a lot like depth first search. I implemented it with recursion, if you're familiar. So we're going to walk through an example. I've picked iambic pentameter as the meter that I want to work with. And I've chosen to represent it here as a set of zeros and ones, where a 0 is an unstressed syllable and a 1 is a stressed syllable. So this is that Shakespeare meter. Iambic pentameter means that there are 5 pentameter sets of iambs, where an iamb is the unit of 2 syllables that are unstressed stressed. So this is like, if music be the food of love, play on. Shakespeare's really famous for using this. So here's what we found so far. We're looking for 10 syllables in that pattern. I picked one of the words out of I Am the Walrus, and it's little. Unfortunately, this does not fit our meter because it is a stressed syllable followed by an unstressed syllable. And so we have to throw it out and pick a different word. I'm. This is 1 syllable. Sure, it can be unstressed. I'm crying. So far, so good. Next up, yellow, matter, custard. And this is great. I'm crying, yellow, matter, custard. You can feel the rhythm in it. Unfortunately, if you're familiar with the song I Am the Walrus, you know there's the word custard specifically and the phrase yellow, matter, custard only appears once in the entire song, which means there's only one word that can come next, and it's dripping. I got cut off a little, sorry. And this gives us 11 syllables, which is too many. We really need only 10 here. We can't tell the computer to be flexible about this, or we can't without a lot of work. And that means we have to backtrack. We can't use the word dripping, but there aren't any other words that come after custard, which means we have to drop that word too, and that's true for the entire phrase. So what else comes after crying? Sitting. All right, that still fits, great. I'm crying, sitting in the sky, still fits. See is our next word. And where our pronunciation dictionary was okay saying this can be unstressed because it's really common, see is not like a filler word. It's not like the and, something that's really common. So our pronunciation dictionary says this has to be stressed because it's an important word. So that doesn't work. And we're going to back out. Sky, nothing comes after it. So we're almost there, though. We're getting close. So I'm crying, sitting in the walrus. What's our next word going to be? Ta-da! So we've got it. We've got 10 syllables in iambic pentameter. I'm crying, sitting in the walrus goo. So that's it. We've got rhyme, we've got meter, and we've got text. We're going to put it all together. So this is Python pseudocode. Like the presentation a few hours ago, this slide is a lie. But we're going to get the idea. Some of these are just going to be helper functions. So our inputs when we're generating a poem are going to be the source text that we're going to use, the meter that we want, and I've used K here as the number of lines we're going to generate that rhyme with each other. So this is going to give us an iambic pentameter couplet. So we start by building our backwards Markov model out of the source text. We find all the rhymes in the text, and then we randomly choose one of those, and we choose our seeds. We're going to choose K of them. In this case, maybe 2. So we're going to pick 2 words that we're going to start with in order to go backwards. Pick our output for those seeds. We're just going to generate a line backwards, and we're going to apply the meter constraints so that we end up with 2 things that rhyme. We are going to have to reverse the output so that we get it in the original text order at this point. Append it to our output, and then join it all together as a poem. And I am not actually going to show you the output of this because it's not that interesting, I promise. The set of words in I'm the Walrus make it pretty limited in what it can generate. But instead, we're going to see what happens when we give it the full power of all the Beatles lyrics. So I have wrapped this generation code in a Flask app, and we are just going to say, I want a sonnet. I've got some pre-built corpuses, but particularly we want one in the style of the Beatles. And here we go. And if just gotta say that go to flirt, can sing it, dig it someday when the tracks, in mind for people running round it hurt, The days are making sure of man the cracks. To hurry, leave, and dig a dose, of course. Good night, I'm crying, yellow submarine. I'm glad it's easy way from rocking horse. Him do that money, that's the limousine. To lost the yard of music mother was, to find the girl of every night arrives. The morning go inside is happy 'cause her into these are living piggy wives. Her lips a ginger sling with anyone was really want that will for everyone. Thank you. Great. Oh. I did have a backup plan. So shout out especially to Pentametron. This is a Twitter bot that once upon a time watched all of the tweets coming through the fire hose, found tweets that were in iambic pentameter, found 2 of them that rhymed and retweeted them in a pair. It was really inspiring, and it's what led me to realize that something like this was possible. Special thanks to Hannah and Al, who helped answer my slide questions, and the first time, all of the resources that people put together for first-time speakers, I wouldn't be up here without those. And Puppy, who reached out to let me give this earlier. And that's it. That's all I have. This is how you find me on Twitter. This Flask app is deployed at this URL, and all the slides and source are at my GitHub. I didn't have a picture of me with a snake, so.
I didn't have a sonnet prepared to outro you, but we'll be back in 10 minutes. Woo!
Together we can save the world. Together we are invincible. Save the world from wars. Save the world from breaking apart. Save us from losing our hearts. Save us from losing our souls. Save us from losing our
Welcome back. Up now we have Elena, who will be speaking about testing asynchronous code. Let's make her feel welcome.
Hello, everyone. My name is Elena Oates, and I work as a software engineer at Lululemon. And some of us do wear yoga pants on a daily basis to the office. So as you heard, this talk is about testing asynchronous code. And I hope you all attended yesterday's talk of John Rees. He was talking about coroutines because it would be very helpful for this talk. But to refresh your mind on what is asynchronous programming, it's a way of it's a concurrent way, not parallel, of executing tasks. And on the diagram on the right, you can see that we have parallel programming where we use a CPU for each task. And in case of concurrent programming, though, we would use just one CPU and one thread to run multiple tasks. But it's different in that way that first we run task 1 for a little, then we suspend the execution on task 1 and run task 2. Then we resume the task 1 again and run it again. But at each moment, you have just one task running in comparison to parallel programming. We use asynchronous programming when we have I/O-bound tasks, such as waiting on data from an HTTP server or from a database. And in Python 3, we use async I/O library to achieve asynchronous execution. Now, here's an example of asynchronous programming, and that's perhaps the most mundane example I could come up with. You can see two functions here. Each of them is printing statements and uses sleep to sleep for a few seconds. We run these tasks in asynchronous mode, in a synchronous way. We create a task for each of those functions. And then you can see when we run it asynchronously, you can see the result on the right side. We spent only 5 seconds in total. In comparison, if we would run this in a synchronous way, this would take at least 8 seconds because each function sleeps for a few seconds. First sleeps for 5 seconds, another one sleeps for 3 seconds. Now, at the heart of async I/O are coroutines. And what is a coroutine? Now, let's first speak about the regular function. This one has one entry point and one or multiple exit points, but only one exit point is used for each call. In case of coroutine, though, we can have many entry points and many exit points. As in case of our previous function, you see we have print in the beginning. That's the entry point. Then we suspend the execution at the sleep because there's nothing to do here, so we can just do something else in the meanwhile. Then we return from the sleep. After a wait, we have another entry point. Then after that, we print, and then we exit. We have multiple entry and exit points. A few things to understand before we continue so that you're aware of the terms we will be using in this talk. Coroutine function. It's the function that is defined with async def, and it can be verified with isCoroutine function method of async I/O. The coroutine object is the call to the coroutine function, or it's also called awaitable. And you can also verify if it's an awaitable object by calling isAwaitable function of the inspect module. Now, finally, when we await for a coroutine object or for the awaitable, we get the result. Now, this talk is about testing, and I hope you know about patching and mocking. I'd like to know how many people have ever mocked or patched something. There's quite a few people, but just to quickly, I'll speak quickly about this. Patching and mocking is used to replace parts of your code so that you can assert that it has magic methods that have default implementation, such as dunder method at the end of the test. Here's an example of simple patching. You can see a function at the top where we sum a range of numbers from 0 to 9. And let's say we want to test that this function was using sum and range built-in functions inside its body. So for that to test, we need to patch the sum and the range. And this will be passed into the function, into the test function as mocks. So you can see range mock, sum mock here. Then we call the function inside the test, and then we assert if this mock was called. If this test passes, it means that range and sum built-in functions were actually called inside our function. If this fails, it means obviously they weren't in the function. Okay, so going back to our coroutine example that I showed earlier, to remind you, the function was very simple. It was just 2 print statements, and we had a sleep in it. So how would we test it? It's pretty simple. It looks very similar to the previous example I showed you of a test. The only difference here that you can notice is that we use async def, so it's a coroutine. This test is a coroutine now. We also have await here because the Sleeping Beauty function was a coroutine, so we need to await for it. Then we assert that the sleep function was called, and we assert that the print function was called as well. Now you can notice here that there's also an additional decorator that I use, and that's the one that is provided by PyTest async.io library. But in my test, I use PyTest to test things. It doesn't mean actually that you would have to use PyTest to test asynchronous code, but it just makes it easier. But this decorator helps us with running these tests that I have here as async.io tasks. Now, one use case of when using async.io would be, let's say we want to send requests for, let's say, 100 resources to an HTTP server. It would be a rather bad idea to do it synchronously because it would take a long time to get data for each of those requests. So we need to wait for each of those requests to end before we start sending requests for the next one. So that's where AIOHTTP comes in handy. We can use it to send multiple requests for an HTTP server and run it asynchronously. So here's an example of using this library. You can see here in the fetch info for pics, that's the main function, I create 20 tasks. In each of these tasks, I'm creating a request to a remote server to receive information about a picture. So you can see I have here a list of 20 tasks. And how do we test this? This example looks slightly more complicated than the previous one. First, I want to bring your attention that we have async with here, which is an asynchronous context manager. And also, one more thing to note to you that when we send a request to a third party, let's say like an HTTP server, in tests, we don't usually send a request to a real server. We mock something like that. So we would want to mock specifically, what things do we have to mock? Specifically, we would want to mock this JSON method call, because that's the one that will return us the data about whatever we're looking for. But if we want to mock this JSON, it means we also want to mock, we would need to mock the response as well. So we have to mock this object as well. Then response is coming from the session get, so we need to mock that as well. And the session has to be mocked as well. And then the client session object too. So we have 5 objects here that need to be mocked in order to test this. And that is basically saving us from sending the data to an actual server. So to understand how to mock an async context manager, we need to know what is an async context manager. For that, we will take a look at the PAB 492, which is about coroutines with async and await syntax. So you see at the top is the context manager syntax, and it's equivalent to the code below. The things you would have to pay attention to is that the manager that we have, the manager comes right after async with keywords, and the manager must have aexit and aenter dunder methods defined for it. And also these methods must be, when we call them, they must be coroutine functions, because we see await here. So we're awaiting, just to remind you, we're awaiting for coroutine objects. So here's an example of that test that I was, for that function I was showing you earlier. This one is using async mock object provided by Python 3.8. And you see I was mocking aenter method, and I was also mocking JSON method, because both of those are, I was using async for them because those are coroutine functions, so I would need to mock them with async mock. For the rest of the objects, I can just use magic mock, and it would work just fine. One thing to note here is that I'm patching here specifically the aenter method of the client session object. If we don't patch and use mock instead, all the tests that come after this test will use the same mocked object of aenter, and we want to avoid that because the next test must have the fresh new client session. Now, the same example that I was showing earlier, you can see in Python 3.7. That you can use in Python 3.7 without async mock, because Python 3.7, 3.6, 3.5 don't have async mock. And for that, you would need to install async test library. And this library provides coroutine mock instead. So coroutine mock versus async mock. Now, this example is slightly longer than the one I was showing you earlier. That's because aexit, for example, has the default implementation with async mock, but magic mock doesn't have it. You see here still that I use coroutine mock for aenter method, and I use coroutine mock for JSON method. And you see here we assert that we got 20 pictures at the end, and it's a list of things that we expect to get. Now, I hope you don't, after all these examples, I hope you don't feel like you're too overwhelmed, because we still need to talk about asynchronous iterators. But I promise it won't be too complicated. You can see in this example that at the top we have an asynchronous generator where we're trying to, or the generator's purpose here is to generate numbers from a range, let's say from whatever we pass it, from 0 to 5. And besides generating that number, it also sleeps for a second. So it must be async def, defined with async def. It's an asynchronous generator. Now, in the main function, on the other hand, we iterate through this generator, and we take a sum of all these numbers that were in that range. Now, let's say we want to test how is this working for, let's say we want to test that the delayed count was called with an argument of 10. How do we do something like that? Here's the test on the right-hand side. We don't care what delayed count actually is, because the only thing we're looking for is to check that this function was called with an argument of 10. So we can just mock it completely. And you can see here, magic mock was used for mocking the delayed count. So I just patch the delayed count here on the right with the magic mock. Then I call the main, I await on it, and assert that this was called with a 10. It's pretty simple. Now, one thing to note here is you may think that the iterations here will be run asynchronously, but it's not true. Each iteration will start after the previous one has ended. However, asynchronous iterators allow you to run other coroutines while the async for is waiting for something. Now, you saw a lot of magic mock and async mock here when I was in the example as I was showing earlier. And you're probably wondering, so which one should I use in my tests? And here's an answer for you. Let's look at this. So async mock is the class, and the call to the async mock is an instance. And it's something similar to a coroutine function. So if you want to mock a coroutine, you would use the async mock instance. Now, the call to the instance, though, is a coroutine object, so they are waitable. So you have to be careful when you need, actually, the async mock. It might be that you don't even need the async mock sometimes. You would be fine with magic mock. So if we look at the magic mock itself, it's a class again. The instance of the magic mock, well, it's an instance. And the call to the instance, though, is again an instance of magic mock. So you see the difference? Async mock was the call to the instance of an async mock is a coroutine object, but the magic mock instance, the call to it is a magic mock. Also, one thing to note is that in Python 3.8, both magic mock and async mock have default implementations of aexit, aenter, and aiter. And that's one of the reasons, back in this example that I had here, we didn't have to use async mock. Like in this test, we could just use magic mock because magic mock also has aiter implementation. Going back here, so when we call aiter, aexit, or aenter methods for a magic mock, this will return an async mock too. So even if you call, like you see here, I have magic mock instance, then I call aexit on it, and I still receive a coroutine object, and async mocks. And that's about it. Thank you for listening.
That was awesome. We'll be back in around 15 minutes or so.
I got your back, just take things slow. Wanna take mine and get close. Understand, I know how things flow. Please just take my word and think you know. We stay up all night writing notes.
welcome back. Up now we have Adi, who will be automating away the open source maintenance burden. Let's make him feel welcome.
Hello. Okay, I think this is working. Cool, so let's get started. So I'm Adi Vajpayee. I mean, you heard that, you know that, so okay. I'm 18. I'm not sure if any of you are that young, maybe young at heart. So I'm from India, long way, but I mean, I'm speaking, so that was reason enough. Then I've been using Python. I think I put that joke in, since 2017. They didn't really teach us that at school because we were taught Turbo C++, which sucks. Sorry, my computer teacher, if you're seeing this. I hope you're not, but it sucked. And I learned Python myself, and it was hard, but it was like working at the FBI. It was on a strictly need-to-know basis. I mean, I don't know a lot of it, but I do know a lot of it. I think so. And I love F strings, yes. And I do also love the walrus operator. I mean, I'm not sure how that sits with all of you, but I do. It saves time, so yeah, that's good. Okay, overview of the talk. So why would we want webhooks? www. I think I did a couple of extra, but okay. Then how do we set that up? How do we secure them? That's important. Then how do you auto-deploy a backend? That was something I had to learn myself because like a lot of people do not use Heroku. Then GitHub API stuff, that's really useful. And then GitHub apps, do you really need them? So, I mean, I put these in order here, but as we move through them, we won't necessarily be following that because it just intertwines and mixes. But I think that's okay. Okay, so right. So this talk is not like the automation talk or like how to make a GitHub bot because like I'm lazy and I'm also lazy at being lazy. So this is also on a strictly need-to-know basis. I mean, you don't really need all of that you find in like a 30-minute YouTube video. So this is not this talk. Our talk is like the friendly neighborhood Spider-Man of automation and maintenance. So you know this, I'm lazy. But if any of the universities I've applied to are watching this, then I'm just faking it for these people. I'm not really lazy. The term is efficient. Cool? Awesome. Okay, so the context. Now I'm going to tell you what application I actually use all this for, so you know where I'm coming from and where I'm going. So this begins in 2017 when I participated in a competition called Google Code-In. It's for pre-university teenagers. You work with like open source organizations. I work with CC Extractor Development. That's me at Mountain View receiving the award from Chris DeBona. He's the director of open source at Google. And he likes to have fun. So when I won this competition, and I had just begun to use Python that year in 2017. So I mean, I was I was on cloud 9. I mean, I could write code that runs every day. I mean, that's run every day since like 2 years or 3 years now. It's 2020. And I mean, I felt like I could contribute to everything. I could write anything. So what did I do? I came up with an application called Swag Lyrics, which is an immature name, but I did not really know that other people would use it. If I had that forethought and I wasn't like, I mean, I was in grade 11, I think. So anyway, what this does is because I like listening to music a lot, so as you're listening along to a song on Spotify, it'll get the song and artist name from Spotify, then parse it and try to get the lyrics of it so you can like sing along. Because it's really embarrassing if you're singing along with the wrong lyrics, then like you go to school, you're singing along, your friend is like, hey, no, that's not how you say that. I mean, no one likes getting embarrassed. So what I did is write a custom parser because you have the song and artist info from Spotify. So I mean, how hard would it be to see the same, to go to the exact same URL page from like genius.com, that's the lyrics provider. So so it's like easy if your song is like this, Hello by Adele. So you can actually see how, this is empirical, like, you know it's easy. But it gets complicated for weirder songs. I mean, this one has non-Latin characters, it has braces, it has featuring artists. So I really had to process a lot of data, identify a lot of patterns, so I could actually support a lot of songs. Now, I try to be a smartass. Like I said, I'm on cloud 9. I mean, I think I can do everything. So I bake in a feature that whenever this application encounters a song it cannot fetch lyrics for, it uses the GitHub API to open an issue on the GitHub issues of the repo. I mean, this is blatant abuse of the issue tracker. Like, I wouldn't recommend this. But I did it. I mean, because I could. Like, I seriously felt like I could do anything at that time. And what I also did was make a master unsupported file. So if I encounter a song I cannot fetch lyrics for, and if you try to play the same song tomorrow using the application, then it won't really try because it like synchronizes with all of it. Okay, cool. Now, then I like put this on GitHub, and then it started gaining traction. So one day I come back from school and, oops, this. So like I've got 214 issues. I mean, I'm back from school, man. I studied all day hard, and now I would really want to just focus on doing interesting stuff, not like just scrolling through issues, trying to see, oh, maybe this even does not have lyrics on Genius. It's not my fault. So that's why I knew that I really needed to go and work on automation of all this. So, and it was really simple to bake in that issue creation feature because it's just one dictionary where you just put in all your variables and like the song and artist name. Then the stripper actually refers to the string that we parse from the Spotify. I mean, this is also a bit immature, but like, I mean, I'm not that person anymore, at least, I'd like to think. So, and this is the whole list of songs that I could see that day, and it was quite annoying. So now we move on to webhooks and how I use them. So first we need to think, what are webhooks? I mean, I Googled it. I didn't really understand what they were talking about, so I Googled a lot more, and I read a lot. So to like explain it like how I would, they're like a person who you just ask something once and they just keep talking. They just keep talking. They don't stop. I mean, currently I feel like that person because they just asked me to go and speak once, and I'm just speaking and I'd be speaking for 25 minutes. So, but it's like if you ask someone the time, they'll tell you the time. But what if you ask them the time once and they tell you the time every minute? That's sort of what a webhook does. But what the webhook says is generally more useful. So they're different from like an API, because for an API you request the info, like you ask the time, and then it tells you the time, that's over. But for a webhook, it keeps telling you stuff as it happens. So we use that to process it. Like, if someone actually tells you the time every minute, then you can actually do something useful with it. So how do you set one up? You go to settings in your GitHub repo, you go down to a section labeled webhooks, and then you see this field. So for the payload URL, you put the URL of where do you want to receive the webhook. Then what type of content do you want? You actually want to use application/JSON instead of XWWW form encoded because it's useful in keeping it secure. We'll get to that later. Then for the secret, you want to put some random string or something, but just keep note of it. Then you can actually select what type of events do you want to receive. So I wanted to receive issue events because when issues are opening, I want to do something like that. Like check if the song actually exists on Spotify, can we actually get the lyrics? This all prevents spam and like I can focus my time more effectively. Now what's a payload? Because the previous slide had like payload URL. So this is what a payload looks like. It's the data that is sent to your webhook URL. So this is actually the issue opened payload. You can see some of it. Now it contains stuff like what was the issue title, and when was it opened. Now this is for some instrumental songs, so this is also one of the things we handled. Now we use the Spotify API to check if the song was instrumental, and if it was instrumental, you don't need to open an issue because there's no lyrics if the song is instrumental. Also, if you see the headers, we use that to keep the webhook secure because most importantly, there's this X GitHub signature field that actually contains the hash of your payload with the secret you defined in the previous one. So that's what you'll use to compare it, and that's how you know that your data hasn't been tampered with. Okay, so securing webhooks. So this is the function I use to check if the signature is valid. For first, you try to get the hash algorithm and the GitHub signature from the payload header. So that's SHA-1, secure hash algorithm. Then we use that with the webhook secret that we had defined, and we basically calculate the hash of the payload. And if it matches the signature we receive from the payload, then we know that okay, this is what we want. So that's what this function does. I mean, it may look a bit complicated, but this looks a lot more complicated. This is used to verify if the request you got was from GitHub or not. So we check for headers. We check if the IP address of the request does originate from GitHub or not. So I mean, I copied most of it, but there's some parts that I actually had to write. So it's useful. So now this is what your secured root should look like. You want to use the decorator in the previous slide that checks if the request is actually from GitHub or not. If it is, then you want to see if it has a valid signature, and if it does, then you probably process it. If not, I'm using the abort code as 418. That's I am a teapot. So yeah. Now, how do you auto-deploy a backend? Like I said, I mean, I don't use Heroku. They have this thing where you can like push to GitHub and it deploys already. But they also have a thing where like if your code doesn't get any hits for like 30 minutes or something like that, they stop running it. So I was using Python Anywhere, and now I also use a few virtual private servers. So they don't actually have this functionality baked in. So what do you do? So like I said, what I was doing previously was I'd push to GitHub, then I'd again push to the backend, which was quite redundant. I mean, I really don't want to waste time. So now how it works is you push to GitHub, then it sends a webhook to your backend telling, hey, code has refreshed. And you do a git pull from your backend to update the code. So like this uses webhooks, and this also uses git hooks to reload your web app. So this is like a bare bones version of it. You check if the request method was a post, then you calculate the path to your GitHub repo. That is basically the file that is housing this code. Then you do a git pull, and if it's successful, you return like code 200, which is okay, or like wrong, which is 400. That is like just a wrong request. Now this is actually what's deployed in production, which looks a lot bigger, but it's not. It's basically handling the different type of events. I mean, you only want to handle the push event, then you want to check if the branch was actually master, because I mean, I use this on the master branch. Then it checks if it's actually getting data or not, and if it is, then it's doing the same git pull thing. And now you'll notice there's a small Discord deploy payload. We'll get to that later in like probably the next slide. Yeah, a couple of slides later. So now how do you make your backend reload? As in, the code has refreshed, but how do you make the changes live? So we use git hooks for that, which are shell commands that are executed whenever a git event takes place. Now there's nothing like a post-pull hook, but a pull is nothing but a fetch followed by a merge, and there is a post-merge hook. So we use that. So for Python Anywhere, which I use, you just want to touch the WSGI file, which is the web server gateway interface, and it takes care of the rest. So I define that, then I make it executable with like a chmod plus x, and that's all. This is located in the Git folder. There's a hooks folder. Then you define this file. So now, how do you know a deploy was successful? I mean, you could again go check for the logs, but you will still waste a lot of time there. So that's where Discord comes in, and webhooks. So Discord is actually a platform similar to Slack, but it's a bit more modern. There's no storage limit. It's used by gamers a lot, but a lot of software companies are also moving to it. Like Flask uses Discord for their community management. So we go there. And now the roles have actually reversed. Previously, we were receiving data from a webhook. Now we're actually posting data. So now we're the person that tells everyone the time every minute. So, okay, you get the URL. You probably want to keep it safe. There's no secret here. And now we post data to that URL, handling the previous push event payload that we had. So we can define stuff like who was the author of the commit, what was the commit title, what is the hash of the commit this has been updated to, what was the timestamp, stuff like that. and then you deploy that. So it looks like this. This is also useful, so like when there's a pull request merge to the backend, it automatically deploys, and I know. So I don't really have to personally check, and if you don't get a message, then you know that something's broken. So this was genuinely useful. The other parts were too, but this was mainly. So now we come to the difference between personal tokens that I was initially using when those 200 issues were opened and a proper GitHub app. So the difference mainly is that a personal token is basically that. It acts on behalf of you. So all of those issues opened, they were like Adi Vajpayee, Adi Vajpayee, Adi Vajpayee. And like, I'm thankful my CS teacher did not see that, otherwise he would ask me, hey, you were at school. How are these issues opened? What were you doing in the computer lab? So yeah, that's not the reason why I switched to GitHub Apps later, but it could have been. So GitHub Apps are first-class actors, as in they act independently of you. There's no me anymore. So another thing is with the personal access tokens, you just get one token, you keep using it, you keep it safe. No need to refresh it. It's really simple, and that's, I mean, how you should start. You don't really want to scale too much. But on the other hand, authenticating with a GitHub app and getting that token, it's a bit more complicated because you first get a private key from GitHub when you register a GitHub app. Then you use that to generate a JSON web token, a JWT, that has an expiry of like 10 minutes. And then you use that JWT to get an installation token for the specific installation you want to work on. So the way that works is that a GitHub app can actually access multiple repositories. I mean, if you've got like Travis CI enabled or something like that, they're probably doing that, but now you know how it works. So every installation has a specific ID. For example, when I migrated my backend to a GitHub app, I only installed it for myself, so it was a bit simpler. So then when the GitHub app is now functioning as an independent identity, it does the same actions, but the only difference is it's not you doing it anymore. So like if you actually want your app to be used by multiple people, then that's also useful because, I mean, it would be weird if your name shows up everywhere. So yeah, and these installation tokens, they're valid for an hour, so you need to refresh them if they're expired after an hour. So what are the code takeaways here? I mean, I copied code from Stack Overflow and other GitHub repositories, so you don't have to. It's just so also I like release the slides, so you don't need to like check out, like remember all the links because these are quite big. So there are the webhook securing functions that I demonstrated earlier. I mean, you don't really need to do much, just copy-paste. Then there's also these GitHub app authentication functions I was talking about with the JWT and the installation tokens and everything. So ultimately, there's like a simple function like get GitHub token that checks if is the previous token expired. If it is, it updates it. If not, continue using the previous token. Then there's also a function, exactly the function I was talking about. Then there's also the auto-deploying route that I demonstrated, the Fig-ish one. So that's what we use to actually deploy the code to production once a Git commit has happened. So there's also other stuff like that Discord thing. It's all in the link, basically. I've just linked different parts of the same file. So if you just scroll a bit, you'll see all of that. Then I think that's it, yeah. So you can see me on Twitter at Clasher in the Rye. I actually love the book, The Catcher in the Rye by J.D. Salinger, so it made sense to derive the username a bit. Then my email is at adivajpayee@gmail.com. I mean, no one really uses email anymore, so if you email me, that will be really nice. Okay, thank you.
That was amazing. Guess what, y'all? There's snacks. Come back in about half an hour, we'll have some more talks.
becomes my frame of mind. My heart is stuck in a loop of your rhythm and right. I tried to replace you with something new. Lost my body, tries heartbreaker on the ground. Dancing about the idea of you. Whilst you decide if I belong to lost and found. You know I'm dying to reach out to you. I'm trying but you can't see. You say my calls never come through. Why can't you just hear me? I'm crying 'cause I can't feel you. My heart's sinking to my feet. I'm lying 'cause I can't touch you. Why can't you just hear me? It seems to have impact on me. I feel pain every time you cry. You say you'll be back before I know it, but you always lie. I tried to get on with somebody that's not you. Must I hide the pain that sits before my eyes? Dreaming about the idea of you. Whilst you decide if I fall or if I fly. You know I'm dying to reach out to you. I'm trying but you can't see. 'Cause say my calls never come through. Why can't you just hear me? I'm crying 'cause I can't feel you. My heart's sinking to my feet. I'm lying 'cause I can't touch you. Why can't you just hear me? You know I'm dying to reach out to you. I'm trying but you can't see. 'Cause say my calls never come through. Why can't you just hear me? I'm crying 'cause I can't feel you. My heart's sinking to my feet. I'm lying 'cause I can't touch you. Why can't you just hear me?
tell me you're okay. Tell me something that says you won't go away. I'm gonna make a better place for you to stay. Take a breath and tell me you're okay. Supposed to
All right. So we're back. We have Brian Ocken talking about multiplier testing effectiveness with parameterized testing.
Thank you. This is so awesome. I'm so happy to be up here. Thank you all for coming out and actually staying this long in the weekend. It's great. I'm giving this talk because I really do believe that parameterized testing is one of the superpowers of PyTest. I believe it will save you time if you understand it, get to understand it, both development time and maintenance time. Development and maintenance time. Maintenance time is non-zero for tests, so pay attention to it. I am, if you don't know me, I'm Brian Ocken. I work at Rohde & Schwartz, and I am a embedded C++ developer there and a team lead. We make wireless communication test equipment. And I also have a couple of podcasts I like to do, Test and Code and Python Bytes. And I wrote a book. So if you want to know more about PyTest, I suggest this book. This is not just the manager slide for you to, I mean, you can print this out and give it to your manager. But I think that you should know that a good, robust test suite will help you be proud of the code that you write and have more fun and less fear. And that's why I do software testing. I don't do it because I have to. I do it because it makes my job better. It's a bonus if your test cases are quick to write and easy to maintain. And that's the part we're focusing on today, to try to help you make your test cases quicker to write. We're going to cover three methods for parameterization. Function parameterization, fixture parameterization. Function is what you'll probably use most of the time. Fixture parameterization is something you use once in a while. And generate tests is a technique that some people, when you need it, it's absolutely amazing for the job, but I actually haven't found a use for it. I've talked with a couple of people that have had great uses for it, but I'm presenting it mostly so you know. There's a couple bits when you get into parameterization and reading documentation, specifically pytest.param and indirect, that you'll run across. You can kind of skim over and glaze over at the end of this talk when I'm talking about that stuff. But I'm bringing it up so that you've heard it once, so that when you do run into it later, it's not scary. One of the things you run across and people ask, or they don't really ask, but I thought of right away, is why the weird spelling for parameterize? There's no E between the T and the R. Apparently, that is completely valid English spelling, but that's something that is considered a UK spelling and not a US spelling. So I actually submitted an issue to the core team to try to get them to allow both spellings, but they rejected it, and so whatever. We need something to test, and I just want something simple. So I picked, I think I got this from a Kent Beck book or something, that or somebody else was talking about testing and used this triangle example. And given three angles, come up with a type of a triangle if there is a right angle, or if there's a right angle there, a right triangle if there is a right angle, if there's one that's 90 degrees. If any of them are over 90, it's an obtuse. And if it is, all of them are less than 90, it's an acute triangle. And if you already know that, you rock, or you're helping your kid with their homework, because I had to look it up. I didn't remember it. Also, this example, I intentionally left one bug in it. There may be more bugs in it, but there's at least one. Without parameterization, this might be a reasonable way to test it. PyTest allows you to write really simple test cases, and this isn't bad. For these, because there's 4 outcomes, I need at least 4 test cases. And these don't look very difficult, but I'm going to need a lot more test cases than this, because I should probably do some boundary values and test some floats and more invalid cases. This isn't enough, and it's already kind of redundant. And for this one-line test case, the redundancy doesn't show up very much. But, I mean, really, in real-world test cases, or test functions, your tests are going to be longer. and the redundancy is going to hurt more. So let's try to get all of this into one function. Oh, I wanted to mention before we move too far, the code at the bottom with the examples. When I was writing this, I didn't really want to keep typing the --TB equals no for turn off tracebacks and -V for verbose. I'm using verbose so that you can see the function names, or the function name and the test node name. And I just didn't want to type it all the time. So there's a PyTest ini file. If this bit of the talk means nothing to you, don't worry about it. I'm just telling you. So moving all into one test. I could do this. I have one test, and I just cycle through all of my test cases, all the triangle examples, and assert on them. I've got the 3 angles and what I expect. Actually, this seems reasonable. I've got them all covered, but there's problems. One of the problems is PyTest only shows me that there's one test being run. There's really 4 test cases. I'd like that be reflected in my results a little bit. Also, if there's a failure, everything's failed. And without tracebacks, I have no idea what failed. So, I mean, I could look into the traceback to see what failed, but this is a bummer. Also, if there's multiple ones, it'll stop at the first failure and it won't test all of them. So don't do this. Instead, function parameterization should be your first go-to toy that you use. This is the workhorse of a lot of the testing I do at work. Well, not exactly like this. This is the basic syntax. There's a PyTest mark parameterize decorator that you put on it. You give it a list. You can either give it a list, or this is the shorthand version where we're giving all of the parameters to the test function as a comma-separated string. This works, and then you give it a list of parameter sets to pass in it, and PyTest will go through and run this code once for each one. So we get out of this test case, full test case, and that long thing at the bottom, all the way from test underscore through all the brackets, that's known as the node ID. I also refer to that as the test case because they're kind of equivalent as far as I can tell. But we can run it all, and this is great. This method of putting the list of parameters right in the decorator, I don't actually use very often. I prefer to pull that list out and put it in like a named list somewhere. I think it looks cleaner. You can also, instead of a list, I can move them to a function. So I can parameterize on a function that returns all of my parameters. This is not just cute and clever, it is very, very powerful. Doing this will allow you to dynamically generate a list of a parameter set it's not really at test run time, it's at test collection time. But that's still kind of runtime, and you can interrogate some other things, even read files if you need to. I have seen use cases, and I've got some myself, where we have a big CSV file or something, configuration, that is read at test collection to generate a test list. It could also be a generator. Well, this seems neat. I can put a generator in there and run all of my test cases. This seems more powerful than it actually is, though. Be careful, because PyTest will go through and exhaust the entire generator at test collection. It does not do it at test runtime. But for the rest of the examples, I'm going to go back to the list form because it's just easier to mentally visualize. And before we get on to the other methods of parameterization, I want to play with some tricks with parameterization and some of the reasons why we use it. In this case, I ran the test, and I've got one failure, but I had tracebacks turned off, and I want to kind of see the tracebacks. So I can run it again, and this time override the any file setting and say traceback equals short. So there's a whole bunch of traceback options you can use. I use short often because it kind of just focuses around the assert. And I also use the --LF, which is last failed, sort of the last failure. There's a long version of that, but I don't like typing a lot, so I memorize the short ones. But this, like in this case, I'm using, it just ran one test case. It ran the last failed one. If there were multiple failures, the --LF would run all of the failures. You can also do failed first, where it runs the failures first and then runs the rest of the test suite. I can also use these test node names that I've come up with to trigger on that. I can say there's a 60 in all the ones with 60-degree angles. So if I want to run all the tests with 60-degree angles, I can use the -K for keyword and just run those. That whole node can also be used to just run a specific test case. This varies in the support within PyCharm and VS Code. They both allow you to run individual test cases, but they're both kind of catching up. I think PyCharm is the strongest right now for doing this. Some versions of PyCharm don't allow you to have spaces in the node ID, but I think they've fixed that, but I'm not sure if they've released it yet. But I mean, it's still you can still run it on the command line if you want to run an individual one. So on the top, I've got the function parameterization that we just talked about. The next way to parameterize something is through fixture parameterization. The syntax here that I show at the bottom of the slide is the basic syntax. I've got test fix, which takes a triangle, and that's a fixture. Well, PyTest doesn't really know what it is. It's either going to be a fixture or a parameterization. And in this case, it is a fixture, and I've just parameterized the fixture. The notation that I've got here with the fixture taking a request object and returning a request.param, the request.param will be filled in with each row of our parameterization. That's just how that works. I'm not thrilled with request.param, but it's the way it is. It's not bad. Where am I going with this? Oh, I'm just running it. So at the basic syntax, I have a problem, though. Because I'm not passing in simple strings as my parameterization, PyTest really doesn't know what to do with the name. I'm passing tuples in there. With fixture parameterization, for some reason, the naming isn't easy for them. And if it's an object of any kind, they just number them 0, 1, 2, 3, whatever. And I don't really like that. So, but there's ways to get around it, and that's what we're going to talk about. The first way is you can pass in a list of identifiers in the fixture decorator. Yes, you can do this, and it works. I don't really like to do this because it separates my parameters from the names, and that seems clunky to me. So it also it's the same IDS parameter to the decorator, but you can also pass in a function that takes something and returns a string as an ID function. Note that just stir or repr are perfectly acceptable things to use there, or you can use a lambda function to pass that in. And especially when you're just like hacking through some test code and it's not finalized, this works fine. To me, I want to see if I can get the exact representation as we had with function parameters. So I'm going to go a step farther. And that's writing my own ID function. Just a couple lines of code, and I end up representing the node ID very similar to what we saw in function parameterization. So although it doesn't do it automatically, that's not really that much extra code to just write a repr function. The fun things about this as well is you can use, as long as it takes the same data structure, you can use the same representation or the same IDS function or ID function for multiple parameterizations and multiple tests. The third technique, which is not really talked about much, and for a while it wasn't even documented very well, is called, there's a hook function called PyTest generate tests. And what this is doing is, I'm showing it to you because it's one of the three ways. But honestly, I don't use it much. I don't think you should grab it right away. But it's fun to see how it, there's reasons why it's here. It's a hook function that will, and this can either exist in your file or the test file, or it can exist in a conf test file. It takes a metafunc object, which is a little weird. It's got a lot of details in it, but it's got details like the configuration of the test system as well. So you can actually grab out command line flags and stuff and use that to generate your test list. So it's pretty powerful. I'm just giving a link to the documentation for this metafunc to see what all the sorts of things you can play with. And I would suggest if you're really interested, go ahead and play with it, try it out. And I swore that I needed generate tests like 5 or 6 times before, but after really understanding the code under test and understanding the fixtures and everything, most of the time those get rolled into either fixture or function parameterization. I'm kind of rolling along pretty quick, actually. One of the last things I wanted to talk about was a couple things that you'll run across in the documentation. One of them is test param. So at the top here, I've got what are my triangles parameter was, the list of parameters. You can decorate that. I guess it's not a decoration, but you can replace that line with a pytest.param and then parentheses, and then all of the parameters that you were putting into the parameterization, and then you can add more stuff. And the thing you can add is either an ID or marks is what I use frequently. What the ID will do is if I run I can use the ID to change the identifier. So I changed the zeros one, and I'm able to call it with the -K, with the keyword call, because I've changed my identifier. We can use the marks also to run specific marks. And this is really handy for different tests, but some people don't realize that you can do that for individual parameterizations too. Very handy if you have a large set. The last thing that is kind of weird that I wanted to talk about is indirect. And I would say, like for the most time, don't even bother with this. But it bugged me that I kept seeing it and I didn't understand it. And actually, when I wrote the PyTest book, I did run it was in there then. I don't cover it in the book because I didn't understand it when I was writing the book. At the time, the documentation was not that great. I'm not blaming other people. There was a lot of, I know it's a volunteer effort. They've done a great job. The documentation for indirect is actually pretty good right now. I'm not sure who fixed it, but it's not bad. Indirect really is just the value that goes to that parameter. And in this case, I've got A, B. I'm thinking of those parameters as A, B, C, and expected. I can say indirect equals, and I can give it a list of those parameters that are indirect. In this case, expected. And in those cases, I'm going to cycle through all of the triangles that I have, and for the C value, so like 30, 40, 60, and 0, we'll get passed into request.param or the expected. No, the expected is the right, obtuse, acute, and invalid. That'll get passed into the request.param for this expected fixture, and I can do some work there. That's the indirect thing. It's indirect. The value is going through another fixture before it goes to your function, your test function. Be very careful, though. You do have to return from the fixture that you're indirecting through has to return request.param. You can really return anything you want, but the test will get the value that you return from this. So if you're returning something else, I'm sure that will be confusing to you and other people. So don't do that. And I would also say, if you're going to use indirect, it's used seldom enough that I would put code block comments or something around to tell people why you were doing that. We looked at a few test cases, and I want to make sure that I want to give you some guidance that I don't think that that's a full set. Just quickly off the top of my head, I came up with others. So if I was going to one of the beauties of parameterized testing is all of my test cases are isolated to a small bit of code. It's a list of parameters. So right here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different test cases listed in essentially 11 lines of code. That's brilliant. But how do you pick test cases? That's not something I'm covering in this talk, but I do want to direct you. I've talked about it a couple times on testing code. Episode 38 and 39, I talk about different techniques for deciding which test cases, because essentially you can't test everything, but there's some rules of thumb that you can use to quickly get like 80% of the important ones really quickly. We covered the three types: function, fixture, and generate tests. And so I just wanted to throw up a slide here so that you had all the syntax together, so you can kind of look at that. They're really not. I mean, yeah, there's special syntax, but it's not that much code. Once you start using it, it's good. It's not that bad to get a handle on. As far as techniques, like I said, I would lean towards function parameterization first. Use fixture parameterization if you need to do some work for each fixture value. Or if you're already, the code that needs parameterized is already in a fixture, then of course that makes sense. And then PyTest generate test is usually when you want to lean on generating your test list from some outside, something else that you can't normally get other places. But most of the time you can do that by putting your parameters, generating those within a function anyway. You can also combine these. You can have multiple parameterized decorators on a test. You can have multiple parameterized fixtures that go into a test, and also generate. You can use all three at the same time. Combination of the techniques, but that blows up your test case space very quickly. So if your tests are slow, be very careful with that. But it's fun to play with. If your boss says to just write more tests, you can use generate to generate a whole bunch of tests really quick. I'm going to leave you just with some resources. Of course, the PyTest book that I definitely I'd love for everybody to read. But it isn't just the same as the documentation online. I wrote this because I wanted a short text that people could read and get their head around PyTest quickly. And I do believe like the first 4 chapters, even if you check it out from the library, it'll get you thinking in PyTest, and the rest of your PyTest learning will be easier. I left links to documentation on the different parameterization methods and generate tests and indirect as well. Links to my podcasts. There's an incredible Slack community at Test and Code Slack. There's over like 800, 900 people there, I think. I may be making this up, but there's a lot of people helping each other out, and it's really an incredible community. And the code that I used is all runnable, and I've got it up on GitHub. I just pushed it like a half an hour ago, so it should be fresh. And that's my talk. So thanks.
Thank you, Brian.
Am I on yet? No. But you can hear me. I got a whole bunch of rocket stickers, so if you want a rocket sticker, come find me.
So we'll have a 10-minute break and we'll get back at 5:10. Hello. All right. So now we have Scott Shawcraft, and he'll be talking about Python's next decade in us.
Thank you. First, I wanted to say, because I am the last speaker, I get to say thank you to all of the previous speakers. So let's give them a round of applause. I feel so lucky to be here, and I'm used to doing technical talks. This is a very big vision talk, so please strap in, and let's go on a little bit of a journey. So this is called Python's Next Decade in Us, but I think we should start by being a little reflective about how we all got here and why we are here. So you get to see some baby pictures of me. This is me on my dad's lap, although I probably look more like my dad at this point than me when I was like 1. But I was very fortunate to grow up with computers in my life. You can see here I'm getting to play around with the keyboard, and there's the computer and then the giant monitor on top. That's what computers have been most of my life. As I got a little older, I got a baby sister who I got to share things with, including the experience of playing games on computers as they were at the time. You can see this is taken out of like a VHS video, which is why the quality is terrible. But I really enjoyed the joy on our faces that we got from just being a consumer and playing on computers. It took a while for me to bridge that gap from going to be a consumer of technology to someone who created it. When I was a teenager, I was 15 in this picture, I got my first computer. This was a Christmas gift from my parents, and literally, like, it's that much of boxes, right? The monitor is gigantic. I think it was a huge, like, 19-inch monitor. And it was a Dell Dimension 8100. You know, the Dell guy. Oh, dude, you're getting a Dell. Well, I got a Dell. I was very privileged to get a Dell. It was a 1.3 gigahertz Pentium 4. It was like, I know, screamed, right? This is right after they, like, broke the gigahertz barrier. And I was so excited to get this awesome computer. Once I had that computer, I did some Linux stuff, I did some web stuff, I taught myself or learned online HTML, not really CSS. At the time, CSS was around, but not kind of the thing you did. It was a lot of tables. So I'm really good at tables. I haven't done a whole lot of HTML since then. But at some point, I wanted to make these websites dynamic, and so I decided to learn how to program. So I went to a bookstore, which is a store where they have books. And in fact, I brought the book with me, but this is a picture of it as well. And I just got out of school, and I actually dated when I learned what a function was. So June 17th, 2002, I learned what a function was. And that's how I taught myself. Thanks to these authors that wrote this book, they were my teachers. But I also did quickly grow out of a book. I was fortunate enough to grow up when there was the internet. Some folks learned to code before the internet. So I dug on the Wayback Machine and found the site that I remembered going to learn how to do the things that I was actually interested in doing, like online polls. I wanted to make an online poll, and so I learned MySQL and PHP. There's a site called Developer Shed, which they shortened to DevShed, and that was my go-to that summer and the few years after that, where I learned more and more of how to program, how to actually use the tool that a computer was rather than just playing the games on it. So at some point, I was like, I'm going to make a desktop app, right? I've been doing all this fancy web stuff, but I've been doing this Linux, and I have this problem that I'm using like Fluxbox. It's not like a traditional window manager style thing, and there was no great way at the time to actually keep track of what programs you had installed and get them in the menu. So I was like, I know what I'll do. I'm going to go to the bookstore again. I'm going to decide which language I'm going to learn now so I can do desktop apps. And I settled on Python. I found a book. I don't have that book anymore because I think I largely just went online and learned it. But I made this PyGTK app to manage what you have on a menu in your Linux computer. In fact, I pulled this image off the SourceForge page that still exists. So thank you so much to the folks at SourceForge for keeping that content around. I have one other SourceForge story. As a beginner programmer, I remember at the time you actually had to write a paragraph or two about what your project was, and you'd send it off to SourceForge, and they get back to you and they say, "Oh yeah, we'll host it. It's cool." And I remember that intermediate period where I was like, "Are they going to accept it? Is it enough?" I'm just like a kid sitting in his room working on stuff, but they did, and I really appreciate it for them for doing that. So that's my story about how I met computers, how I started using computers, how I started programming them, and how I found Python. And I want to just take 10 seconds for everyone to think about that. What was your first computer? What was your first programming language? And how do you find Python? So think about it. All right. I don't know how long that was, but we'll call it. I hope that brought some nostalgia back to you. It's certainly digging through these old photos did for me. Now that I've talked about myself, and you've thought about yourself and your experience, let's broaden this. Let's go the other direction and talk about computing trends. And where do you go to look at computing trends? None other than the Stack Overflow survey that they publish every year. I took this out of the 2019 one. This is the most popular technologies in 2019. We can see that Python is 4th, which is awesome. Remember that people can check multiple technologies, so these numbers definitely don't add up. If we scroll down, we get a summary of it. The summary says, for the 7th year in a row, JavaScript is the most commonly used programming language, but Python has risen in the ranks again. And then they end with, Python is the fastest growing major programming language today. That's pretty exciting, right? You want to applause? I think it's pretty exciting. And that's to credit everybody who's worked on Python. Now, what do you think the most important piece of information on this slide is? It's probably the thing in gray, right? The most important thing is definitely always in gray. And that most important thing in my mind is the number of responses that Stack Overflow got to create this chart. That number is 87,354. As somebody who developed a lot of websites nobody ever used, that's a big number, right? Maybe that many people use CircuitPython, which is what I work on now. But in reality, how big is that number actually? How many people are there in this world? Well, I looked it up. Some smart people have come up with an estimate, and that's 7.7-ish billion people. That number is much, much bigger than the number who took the Stack Overflow survey. And let's reimagine that chart and combine everything. I've corrected the chart. I've introduced a category called not coders and coders. And I munged all the languages together because I think this is the most important bit. The most important bit, and these numbers here are the total number of people in the world, 7.7 billion, over the 87,000. So we'll adapt it a little bit. But for every one of you in this room and everyone watching, there are 200 people that do not know how to program a computer. I mean coders in the broadest sense, so think about that. Think about what you've been able to do because you know how to use a computer, and imagine that there are 200 people that are unable to do that. I looked up the actual number that people estimate for developers, and it turns out it's more like 24 million, 23.9 million. And that was at the end of 2018. That number is a lot larger than 87,000, but it's still not that much. We still have 0.31% that are coders of everyone in the world. Now, the other aspect is that not everyone in this world has a computer. There's a lot of us, and not everyone owns a computer yet. But how many people do have a computer? Well, those computers they have are not like the computers that I grew up with and many of us grew up with. Last year, I looked up the numbers. These are from Gartner for total sales last year. And there were 261 million sales of desktop and laptop computers. On the smartphone side, there was 1.5-ish billion smartphones sold last year. That's a lot, right? That's a ton. I looked up a number for how many mobile phone connections there were in the world, and it was 5.1 billion people have access to mobile phones. That's about more than half of that are smartphones. So even if we adjust all of these numbers, we lower the total number of people we think could code because they have a computer, we raise up the number for how many people are actually developers, we still find that there are 200 people. I gave you a stat too early. 200 people for everyone here and watching in the world that can program on a computer. There are 200 people who cannot. That's astounding to me. And that makes me feel like when we talk about is JavaScript better or is Python better or is Rust better, we're not asking the right question. The right question is, we are all on the same side, and what can we do better to bring these other 99% of the world into our club where we know how to program computers, and we can use them as a tool, as the tool that they are. So let's take a look at other languages and see what awesome things they're doing. Rust, if you haven't looked, the first thing I want to talk about is that they're doing really, really cool memory management things. There is no garbage collecting. You have to pay attention to what memory is used by whom and how long. But they have really nice mechanics so that the compiler can verify the things that you're assuming. They call it safe code. And if you've ever done C, like I have, you know you're living in the Wild West of probably correct, but definitely unsafe code. And they're building a tool so that they can be safe. I love this tagline on their website. I pulled this last week. It says, "A language empowering everyone to build reliable and efficient software." Not just the people visiting the website, but everyone. The other aspect of Rust that you should really pay attention to, and I put the YouTube link because you should go watch this talk. It's a talk by Emily Dunham, who's at Mozilla, and was one of the people involved in the early Rust community. This talk is all about the things that you can set up so that your community is welcoming and inclusive. It is so good. I've started a community in the last few years, and I borrowed so many of the ideas from this talk. I highly, highly recommend it. That's the other thing that Rust has been doing really well. I was doing an app on a phone, and I was using React Native. I was looking at the React docs, and I came across their documentation page. It has a languages button in the top right-hand corner. Turns out of 7.7 billion, not everyone speaks English. In fact, there's a lot of people who don't. And they've taken the effort to translate their docs into many different languages. This is just the top of the page, and what you'll see is this section is the documentation that has been translated enough that they feel comfortable saying it's ready. So there's just 4. I think there were more. I didn't actually count. But if you scroll further down the page, they're like, here's the other docs that we have in languages that need some help and need some work. It's a call to action immediately on the page, and they're doing that to be as inclusive as possible. And I think that's really, really awesome. Lastly, I want to point out Jupyter and Colab. They're inverting code in my mind. Whereas I read a lot of code and I put in comments, and like as we said earlier, the most important stuff is in gray. Typically, your editor will make your comments gray. But Jupyter and Colab are really interesting because they invert that paradigm. They are a prose-first way of programming computers. I think that's really cool, and I applaud them for it. So that brings us back to Python. Thank you. We are doing awesome, I think. Python is an amazing, amazing language, an amazing community. But I want us to ground ourselves in what we talked about earlier, how we came to Python, why did we use it, and as we go forward, think of that. So think about, what will Python be in the next 10 years? What will you be doing with Python in 2030? Is it weird if I say it like that? How much effort will we be putting into the 2038 problem? Does it even have it? I don't know. There's so many things that Python can do. We saw painting, like co-artistry. We saw poetry. And now, what if you bring these 5.1 billion people into Python as well? What will Python or any other language or any computing thing be able to do if those 5.1 billion people can use it? So, I am not going to try to predict the future. I think a lot of people have made that mistake. But I do want to give you a guideline on how I think we're going to get there. And I'm going to do that by repurposing the notion of TLC. Tends to stand for tender love and care, but I'm going to call it something else. The first one is teach. For every one of you, there are 200 people who do not know how to code. Please help teach them how to. That doesn't mean you have to sit down next to them and help them code or teach them Python or whatever language you're comfortable with. It can be in a variety of forms, right? Like my first experience was something called a book. If you want to author a book to teach someone else, that is awesome. If you want to create a live stream of the code that you do, that is awesome. People will see it on YouTube. If you want to write a tutorial on a site called DevShed, I'm sorry, it doesn't exist anymore. But there are plenty of other sites where you can write tutorials for people. And by doing that, we'll listen to the people that we're teaching. It is the internet. They will let you know what they think. If they're mean, block them and don't listen to them. But if they're nice, think about the terminology that they're using when they ask a question. It might be weird to you, but that's good because we should reintegrate that terminology into our documentation because someone is thinking about it like that. Think about the things that they're trying to do with it. Ask them the big picture. What is the problem you have? Are you using Fluxbox and you want to make sure all your programs are in the menu? Let me help you do that. It may be something different. It might be sculpting. We've seen painting, but what if it's like chiseling out a piece of stone? I think we could see that in the next year. How awesome would that be? One of those 5.1 billion people, I'm sure, know how to do it. We've just got to get them there. So listen to what they're doing. Lastly, contribute. Once you've learned the things that people need and how they think about it, you're going to find all these bumps in the road. Like somebody, I tried this and I got to this point and it was just so hard, right? We've all heard that somebody they fell off, it was too hard. Step back, contribute to the projects, smooth out the bumps. The more people we have involved, the more diverse what Python and coding and computing can do. Contributing can be any sort of thing, right? We are coders. It doesn't have to be code, though. There's so much more to coding than code itself. There's documentation. I talked about languages, but there's also testing and issue filing and answering questions on a support forum. Don't forget about those things because those things are what characterize a project, not just the code itself. All right. I've gone fast, so we'll all be able to get out of here. But first, I want to recap what I've talked about. And I reiterated or I changed the name of my talk. It's not Python's next decade. It's computing's next decade. Python is a part of that, and who knows how big that part will be come 10 years. But it doesn't matter. because if we're in a better spot, we'll be in a better spot, and that's cool. And it doesn't just involve us, thank you, it involves everyone, all 7.8-ish billion people, and the people to come as well. They're not going to have, we talked about and reflected on our experiences with computers and what they were. They're not going to be a computer with a giant monitor. I don't think people are selling those anymore because they're really heavy. They're going to be a phone or a computer you can hold in your hand. And how does that change the paradigm of, like, I want to sculpt something out of stone, and yet I have a phone? How does that work? How does that person go from thinking about a computer as a gaming device or something they read the news on to something that they understand, crunches numbers one after another just insanely fast? But everything that it's doing has been told either explicitly or implicitly by a person to do it. So, totally blanked. This is the part I was worried about most, the end. So what do? I was not going to make predictions about having 512 gigabytes of RAM be the most you could ever need. But I wanted to say, I know how we can get there, right? You can teach, you can listen, and you can contribute. And if we all do that, we're going to end up in an awesome spot in 2030 and beyond. Thank you.
Hi, folks. Regardless of what Scott said, please don't leave yet. I am your bonus content for today. Your DLC, final boss, hidden boss, right? That sounds more appropriate.
I don't know, but I'm turned off.
You are.